Hello, and welcome to The Sleepy Physicist. I'm truly glad you found your way here. Whether you're curled beneath a quilt, eyes heavy with the day's weight, or simply letting your thoughts wander as you rest, this space is for you. Tonight we begin a slow journey, one made not by footsteps, but by quiet imagination. A journey deep beneath your feet, into the warm, ancient heart of our planet. We're going to talk about something vast, something powerful, yet something that sleeps so soundly we almost forget it's there. The supervolcano, a word that feels too big, too loud for bedtime. But I promise, tonight even this giant will speak softly. And don't worry if the science makes your eyelids heavy, that's part of the magic. Sometimes the most wonderful ideas are best explored at the edge of sleep. Now, let's close our eyes to the world above and open them ever so gently to the world below. Beneath your back, beneath the floor, beneath the layers of stone and soil, the earth breathes. It's not a breath you can hear or feel. It is slow, so slow it spans centuries. But it is always there. The planet beneath you is not still, even if it feels that way. It shifts, sighs, and stirs beneath your every step. Tonight, we follow that breath. We go inward, not upward. Down into the crust, down through layers of cooled lava, ancient rock, shifting minerals. We descend slowly, like a feather falling through stone. Eventually we arrive somewhere warm, somewhere deep, a magma chamber. It is not a cavern as you might imagine, no hollow cathedral of fire. It is more like a sponge of molten rock, half liquid, half solid, slowly churning beneath the surface. A molten memory of the Earth's fiery youth, held in suspension. It glows in the dark like embers under ash. This is where the story of a supervolcano begins, not with an eruption, not with destruction, but with silence, with pressure, with stillness that waits. Magma forms when the Earth's deep heat melts the rocks above it, heat that rises from the planet's core, a leftover flame from when the Earth was born. It seeps upward through the mantle, collecting in reservoirs just below the surface, waiting, but magma isn't patient. It presses outward, pushes upward, expanding like a deep exhale that never quite escapes. The rock above it stretches and cracks. Over centuries a volcano may form, sometimes tall and conical like Mount Fuji, sometimes low and wide like the Yellowstone caldera. But a supervolcano is something different. It does not rise quickly. It does not always look like a mountain. It is a hidden titan, a massive reservoir of magma beneath a seemingly ordinary surface. A meadow, a lake, a forested valley. You might walk across it and never guess what lies beneath. Until one day the pressure becomes too much. But not tonight. Tonight the supervolcano sleeps. It slumbers beneath geysers and hot springs. It murmurs in tremors too small to notice. It exhales sulfur, water vapor, the tiniest traces of its presence. Its breath joins the wind, unnoticed. Yellowstone, the most famous of them all, is not a mountain but a vast, gentle swell in the Earth's surface. Its caldera spans nearly 45 miles across. Yet to the eye, it's just forest and sky. Bison grazing, rivers winding, tourists taking pictures, unaware they stand above an ancient beast. A supervolcano eruption is rare, extremely rare. So rare that only a handful have occurred in the last few million years. But when they happen, they change everything. Not just the land around them, but the sky, the climate, the air we breathe. Yet for now, and perhaps for lifetimes to come, the chamber sleeps. Think of it like a great balloon under the surface, slowly inflating ever so slowly, over tens of thousands of years. The Earth's crust flexes above it, but holds. Occasionally there are earthquakes, sometimes small bursts of gas. These are the gentle stirrings of the sleeper. You might wonder, why study such quiet things? Because in their silence lies power. And in understanding that power, we learn about our planet, not just how it might surprise us, but how it lives, breathes, and grows. We study because the Earth is not only where we walk, but who we are. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were born from fire, some from stars, some from volcanic ash settled in ancient seas. The volcanoes of the past gave us mountains and valleys, soil and atmosphere. Even destruction can be part of creation. Even silence can hold stories. So tonight, as your body softens into stillness, remember that you're resting on a living world. A world that churns in its sleep. A world with a heart of fire, covered gently by blankets of stone and snow. And when you hear the wind rustling trees, or feel the soft tremor of a distant train, imagine the Earth's deeper rhythms, slower than seasons, longer than lifetimes. Imagine a breath that takes 10,000 years. That is the rhythm we follow tonight. And as we lie here, wrapped in quiet, we might wonder, how does the Earth speak when it cannot use words? We'll listen more closely in the next chapter as we begin to understand the subtle language of magma. It begins with a shimmer, not light but heat, a ripple through the rocks, unseen, unfelt, yet powerful in its patience. Beneath the stillness of continents, magma is whispering. You might imagine magma as a fiery river raging through caverns, but the truth is softer, more secretive. Magma forms slowly, deep within the earth, where pressures grow heavy and temperatures rise past the melting point of stone. It begins not as a flow, but as a transformation. Solid rock softening into something new, a slow unravelling. This is how the planet speaks, not in words, not in sound, but in movement. In the way minerals melt and mix, how gases bubble and rise. It's a language of heat and chemistry, a language that unfolds over centuries, in syllables of pressure, in the punctuation of tremors. You're listening now, you're still. And the deeper you go in your mind, the more you begin to understand. Magma is not one thing, it is many. A molten mixture of silicates, metals, dissolved gases. Like a soup stirred in the dark, it changes with every shift in pressure, every cooling edge, every encounter with a new layer of stone. Some magmas are thick and sluggish, filled with silica, clinging to the chamber walls as they move. Others are thin and eager, racing through cracks and faults with speed. Each variation in composition changes how magma behaves and how it speaks. When it is thick, it holds onto its gases like secrets trapped inside. Pressure builds. It wants to expand, but the weight of the earth holds it in place. Until one day the pressure wins. When it is thin, gases escape easily. It hisses and bubbles like a simmering pot. Eruptions from this type are gentle. Lava flows that stretch across fields, glowing and slow. But supervolcanoes don't erupt gently. Their magma is thick, heavy, secretive. It stores its pressure for millennia. And when it finally speaks, it does so in ash and thunder. But even that story is told slowly, through signs we can learn to read. Tiny earthquakes begin the message, like a tapping at the door. As magma moves upward, it shifts the rocks above it. Cracks open, the crust stretches. These seismic whispers often go unnoticed, but seismologists listen carefully, measuring each vibration. Next comes the swell. As magma gathers, it pushes the surface upward. The ground may rise just a few centimetres a year, but over time it tells a story of growing pressure. Instruments called tilt meters and GPS receivers record every gentle tilt and pulse. We begin to hear the magma's breath, then there are the gases. Carbon dioxide, sulfur dioxide, water vapour. These seep through the cracks long before magma breaches the surface. Scientists sample them, analyse their concentrations. A change in gas can mean a change in behaviour. The magma is changing mood. And finally, there is heat. As magma nears the surface, it warms the rocks and waters above it. Geysers become more active. Springs steam with new energy. Remote satellites sense the infrared signatures of a planet beginning to stir. All of these, earthquakes, swelling, gas, heat, are parts of the language. The slow grammar of an ancient being. A language we are still learning to translate, but it's always there for those who listen. You now are one of those listeners. You are lying in the stillness of night, and your mind is reaching downward into the warm dark. You can imagine magma pooling beneath the earth, the way honey pools at the bottom of a jar. You can see the crystals within it forming and dissolving, like thoughts that never fully take shape. And just as magma rises, slowly and insistently, so too does your understanding. You're beginning to feel the scale of it, how old this story is, how slow and sacred it's unfolding. We often think of language as something fast, spoken, written, hurried. But this is a different kind of communication, one that asks you to slow down, to be patient, to trust the pauses between the pulses, because magma doesn't just speak to volcanologists and instruments, it speaks to landscapes, to climates, to history. Entire ecosystems are shaped by the presence of magma. Soils made rich by ancient ash, mountains pushed upward by long-cooled chambers. Even the air we breathe has been touched by the gases released in ancient eruptions. We live in a world still shaped by silent conversations beneath our feet, and perhaps that's why it feels comforting to imagine it now, here in the quiet of your room. Your body's still, but your awareness deep beneath you, wrapped in warmth and mineral memory. You're lying above a storyteller, a patient one. A magma chamber takes its time. It doesn't speak in hours or days, but in thousands of years. It builds tension like a breath held deep. It softens rock into liquid thought. It composes pressure like a note not yet played. And when it does speak, truly speak, the message is felt everywhere. But we are not there yet. Tonight the magma simmers. It hums in frequencies too low for your ears. It rearranges atoms. It prepares, but does not act. It holds its voice. And in this silence there is beauty. There is meaning. There is the beginning of understanding. You are learning how the earth speaks without speaking, how it burns without anger, how it waits without forgetting. And as you lie here, eyes closing slowly, you may find yourself wondering, what shape does that waiting take on the surface? Above the magma, what signs does it leave behind? That is where we'll go next. To the scars and circles, the marks in stone left behind when silence was finally broken. The story of the caldera. You've felt the breath of magma beneath you. You've heard its unspoken language, the way it stirs and shifts, slow as time. Tonight we rise just a little toward the surface, to where the planet's stories are written in shape, in stone, in silence. Imagine standing in the centre of a vast meadow. The land is flat and wide, fringed with distant hills. Trees sway gently in the wind. The sky arches quietly above you. Nothing feels unusual at first, but if you listen and look carefully, you'll sense it, a subtle bowl-shaped curve in the land. You're standing inside a caldera. A caldera is not a hole, not a crater in the violent sense. It is more like a memory, a place where something enormous once stood and then fell inward. It is the echo of an eruption so vast that the mountain couldn't hold itself anymore. Long ago, perhaps 100,000 years or more, there may have been a tall peak here, a volcano standing quiet or steaming slightly, hiding its pressure beneath. And then, in a moment written across weeks or days, the magma beneath it surged upward and out. The mountain erupted not just from a single vent, but from fractures all along its sides, releasing ash and lava in all directions. The magma chamber, once full, emptied too fast. With nothing left to support it, the mountain above collapsed inward. The caldera was born. Now it rests like a great stone nest, wide, shallow, and calm. Lakes often form in its centre. Valleys bloom. Life returns slowly, unaware of what once tore the sky above this place. But the land remembers. Calderas can be vast, miles across, like Yellowstone's 45-mile span. They don't always look dramatic. Some are subtle, hidden beneath forests covered in grass. Others are filled with water, like the stunning blue circle of Crater Lake in Oregon, the remnant of Mount Mazama, which erupted around 700 years ago. You might walk across a caldera and never notice, but the ground beneath you holds a different kind of gravity, a quiet tension, a scar, healed but not forgotten. You may wonder, why does the Earth choose this shape? Why collapse instead of rebuild? It has to do with balance. When magma exits a chamber quickly, the space it once filled becomes hollow. The roof, miles of rock and sediment, can't hold itself up. Like a souffle collapsing after heat is turned off, the ground sinks. But unlike a souffle, the caldera doesn't disappear. It remains, vast, still, holding echoes. Geologists study these shapes to understand past eruptions, the tilt of the walls, the age of the ash layers, the alignment of cracks and vents. Each detail tells of what happened in those distant days, when sky and stone traded places, when mountains became bowls. You, lying here tonight, may begin to picture it. A ring of land, a curved horizon, perhaps mist curling low over the valley, perhaps birdsong returning after centuries of quiet. And as you imagine this bowl of stone, you might think of your own breath. How the lungs too expand and release, how the chest rises, then falls inward, soft and natural. The earth is not so different. It inhales molten pressure, It exhales eruption. Then it rests. A caldera is that rest. It is the moment after the storm. Sometimes life thrives here. Calderas can be fertile. The ash from past eruptions enriches the soil. Warmth from the Earth's lingering heat nourishes hot springs, geysers, and unique ecosystems. Trees grow in rings. Birds nest in ledges carved by fire. But the calm is not always permanent. Some calderas, like Yellowstone, are still active. Magma still moves beneath. Heat still pulses upward. Geysers speak. Earthquakes murmur. The scar may reopen someday, not to wound again, but to release once more. That's what makes the caldera so humbling. It is not merely an ending, it is a pause. A silence with memory. A waiting breath. You are resting now, wrapped in that silence. In the stillness of your room, your thoughts sink gently downward, as if settling into the curved basin of an ancient caldera. Safe, warm, surrounded by walls carved by time and pressure. This is not a place of danger tonight, it is a place of reflection. A place where the earth remembers what it once held and what it might hold again. There is something deeply comforting in this shape, in the circle, in the way nature returns to what was broken. The circle closes, but stays open enough to change. It holds space. Perhaps we do too. Perhaps we each carry landscapes like this within us. Places shaped by pressure, collapse and regrowth. Places where something once rose and then fell inward, and in the falling made room for something new. The caldera is not a scar to fear, it is a shape of wisdom. And as we leave this gentle valley of memory, you might begin to wonder, what lies above such a hidden giant? What does it mean to live, day by day, atop something that sleeps but still breathes? Next, we'll travel to one such place, a plateau that steams with breath where forests walk above fire. Yellowstone is calling. Imagine a place where the earth breathes so openly you can see it. A place where the ground whispers in steam, where colours bloom in pools not from flowers but from heat, where the stillness of pine forests is interrupted only by a slow rising hiss, as if the world itself is sighing. This is Yellowstone. At first glance, it seems like any other wild place, a land of rivers, wolves, elk, and snow-draped trees. But beneath the soil, deeper than roots can reach, lies something enormous. A sleeping supervolcano, its presence both quiet and vast. It doesn't shout, it doesn't tower, it waits. And while it waits, it breathes. Tonight, we wander through this landscape slowly, like mist curling through a canyon. You walk in thought, not on foot, through Yellowstone's gentle silence. Beneath your imagined steps lies the caldera, wide and hidden. Above, the stars blink. Below, the magma shifts ever so slightly in its warm bed of stone. Yellowstone's surface reveals its secret in scattered clues. You might see a geyser erupt, a plume of steam and boiling water shooting into the sky, or a mud pot bubbling thick and grey like a pot of soup stirred by invisible hands. Fumaroles whisper, releasing warm breath into the cold air. These are not ordinary features. They are the Earth's pressure valves, signs of something deeper, a reservoir of molten rock that lies perhaps just 8 kilometres below the surface in some places. Closer than we think, closer than we usually allow ourselves to imagine. But tonight, we allow it. We feel its presence not with fear, but with wonder. The ground here is thin, geologically speaking, like parchment stretched over a slow fire. Yellowstone sits atop a hotspot, a place where heat from deep within the earth rises persistently, melting rock, warming water, shaping land. Over millions of years, this hotspot has moved, or rather, the land above it has drifted, like a conveyor belt carrying continents. As the North American plate slides westward, the hotspot remains rooted, punching through at intervals, forming volcanoes like footprints across time. Yellowstone is the most recent, the most restless of these. Its last massive eruption happened around 640,000 years ago. It reshaped the landscape, carving out the caldera we now explore. It spread ash across continents, but in its long sleep since then, the land has healed, at least on the surface. Bison graze, tourists gaze, children dip their fingers in warm streams. It is easy to forget what lies below, and yet reminders are everywhere. Scientists measure the ground and find it rising slowly, by a few centimetres each year. They listen to the soft rumbles beneath, tremors not enough to shake the trees, but enough to mark the magma's subtle shifts. They study gases rising from vents, looking for changes, like doctors reading a pulse. Yellowstone is monitored constantly, lovingly, with awe and care, not out of panic but respect, the kind of attention we give to something alive. And make no mistake, the land here feels alive. The colours in its thermal pools are created by microorganisms, thermophiles, that thrive in boiling water. Some feed on sulphur, others on iron. They paint the edges of pools in brilliant shades of orange, green and gold. Life clings to heat, thrives in extremes. Even here, in a place shaped by fire, life finds a way to bloom. The most famous geyser here is Old Faithful, named not for its height, but its rhythm. It erupts roughly every hour and a half, sending a jet of steaming water skyward. Beneath this momentary drama lies a complex system of underground plumbing, tubes, chambers and pressure points, warmed by the supervolcano's breath. Every eruption is a release, a letting go, a moment of peace before the pressure builds again. There is something deeply calming about that idea, that even deep beneath the most powerful forces, there is balance, steam escapes, heat flows, the earth finds ways to keep its calm, and so do we. You listening now may feel your own rhythm slowing. Like Old Faithful, your body follows a pattern. Inhale, exhale, tension, release, quiet returns. We can learn from Yellowstone, from how it holds both beauty and power, how it allows pressure but also manages it, how it sleeps deeply but not silently. This land does not ask to be feared, it asks to be listened to. You can picture the map of it in your mind, a wide valley ringed by forests shot through with rivers and lakes. Beneath, a chamber of warmth. Above, the open sky. You are standing in thought on the shoulder of a giant, not a cruel one, just a sleeping one, a powerful, patient presence that shapes the world not with rage but with time. It might sleep for another 100,000 years, or 1,000,000, and in that time life will go on. Trees will rise and fall, snow will come and melt, steam will whisper through the pines. The land will remember what it holds, but it will also offer peace. That's the nature of Yellowstone, a place where fire and forest meet, where the ground sings quietly of ancient flame but gives you shade to rest beneath. As your breath softens now and your thoughts begin to drift, you may feel the warmth of that fire, not as danger, but as depth, as something that connects you to the earth, gently, deeply. You're part of this planet, part of this quiet story. And now, as your mind settles like ash on still water, you might begin to wonder, what are those whispers of steam trying to say? What if the geysers themselves are speaking? Next, we'll follow the breath of the earth as it escapes in steam and song into the world of geysers and the language of water and heat. Now that you've walked the quiet floor of Yellowstone's caldera, felt the weight of its history, the hush of its sleeping strength, we move in closer. Not deeper underground, but closer in attention, to the details, to the small rhythmic breath that rises from the ground again and again, like a slow exhale in the cold morning air. Tonight, we follow the breath of geysers. Steam curls from cracks and pools in the surface like smoke from an invisible fire. It rises in soft spirals, a dancer made of warmth. The sound is gentle, a hiss, a murmur, a sudden sigh. And then, sometimes a geyser speaks, not in language but in rhythm, in release, in rising towers of water, flung skyward with astonishing power, only to fall again like rain that never touched a cloud. You lie still now, your body quiet, but your mind is walking beside a geyser field, maybe in Yellowstone, maybe in Iceland, maybe in your own imagined landscape of boiling breath. The land feels alive beneath you. It pulses gently. There is warmth in the air, and something ancient in the way the ground exhales. So, what is a geyser, really? It begins with water. Simple water like the kind that falls as rain. It seeps down through cracks in the earth, through porous stone trickling deeper and deeper until it meets the heat below, the warmth of magma still resting beneath the surface. There, deep underground, the water collects in pockets. It heats slowly. And unlike at the surface where water boils at 100 degrees Celsius, this trapped water can become superheated, reaching temperatures well above boiling but without the freedom to turn into steam. Pressure holds it down, keeps it liquid, until at last the pressure tips. Just a tiny bit of that superheated water flashes into steam. It expands violently, the rest of the water follows, a chain reaction of sudden, irresistible change. Steam rises rapidly, pushing water upward through narrow passageways. The earth trembles. Then, release. The geyser erupts. And then, peace again. It's a cycle, a breath, an inhale of heat, a long pause, and an exhale of steam. Some geysers erupt on a precise schedule. Like Old Faithful, always returning. Others are more secretive, waiting hours, days, or even years between eruptions. Each has its own rhythm, its own story. You can think of the geyser as Earth's lung. Inhale, water seeps in, collects, warms. Hold, pressure builds, temperature rises. Exhale, a rush of steam and sound and spray. Then stillness. And in that stillness, something beautiful lingers. The pools left behind shimmering colours too vivid to describe easily. Deep turquoise, soft gold, brilliant rust. These hues aren't just light tricks, they are living colours, created by thermophiles, heat-loving microorganisms that thrive in boiling water. Some feed on iron, others on sulphur. Together, they form rings and patterns at the edge of the pools like watercolour paintings made by life itself. These quiet life forms have been here for billions of years, long before us. They may even resemble the earliest life on Earth, simple, resilient, ancient. They survive in scalding heat in acidic water. They don't fear the breath of the geyser. They belong to it. And you, lying in this moment of reflection, belong to it too. Not in body, perhaps, but in thought, in rhythm. There's something comforting in the predictability of it all. The way pressure builds, then releases. The way heat finds a way out. Nature rarely holds on to tension for long. It finds a path, a pattern, a pause. We too hold pressure, in muscles, in minds, in unspoken thoughts. But like geysers, we can learn to release. Not with eruption, but with breath. With warmth. With gentle rhythm. Even now you might find your breathing slowing to match. Inhale, hold, exhale. A mirrored cycle, a shared language. Geysers have taught us more than rhythm, though. They are also clues. Clues to what lies below. Scientists study their frequency, their chemistry, their temperature. They can tell when the underground systems change, when the heat shifts, when new vents form. A sudden silence from a regular geyser can mean something is stirring deeper in the system. Geysers are messengers, not of disaster, but of change. And what poetic messengers they are. Their message written in mist and heat, not ink or speech. They don't cry out. They rise, speak, fall silent again. They remind us that expression doesn't have to be loud to be profound. You might picture one now, steam rising in the moonlight, a thin tower of water arcing into the air, then falling in soft drops on warm stone, the hiss fading into quiet, the pool settling again. In that image is a lesson. To rise, to let go, to return. You can almost feel the warmth on your face, the gentle spray on your skin, even as you lie tucked in bed. That's the power of these places. They find you wherever you are. Their rhythm lives in your pulse, in your lungs, in your thoughts. And tonight, as you drift even closer to sleep, perhaps the geyser's voice stays with you. Not the sound, but the feeling. That rising, that release, that calm. You are made of water, of breath, of heat. You too can let pressure go. Let the night be your geyser field. Let each thought rise and fade like steam in the cold. Let your mind settle in warm silence. And as it does, a question may rise, slowly, curiously, like a bubble deep below. What happens when that steam becomes ash? When breath turns into something heavy, something dark that falls from the sky? We'll follow that trail next, into the strange snowfall of volcanic ash, and the way a single eruption can hush the sun. The geyser's breath has faded now, its warmth resting in the stones. Steam has risen and curled back into the sky, and the earth has gone quiet once more. But not all of Earth's exhalations are warm. Some come not as mist, but as ash, a different kind of breath, a darker one. Tonight, you lie in a quiet room, but outside the window of your imagination something extraordinary is unfolding. The sky is changing colour. Not quickly, not dramatically, just enough to turn blue into grey, gold into dim. The light softens. It becomes hard to tell what time it is. Morning looks like evening. Shadows disappear, and then gently it begins to fall. Not snow, not rain, but something finer, something softer. Ash. It drifts down like dust from an ancient attic, silent, steady. At first it is almost beautiful, the way it coats tree branches, the way it catches the muted light. But this is no ordinary dust. This is volcanic ash, not soft but sharp. Not from decay but from eruption, a breath of rock shattered into dust and carried on the wind. You are witnessing what happens when the earth speaks in full voice. When a supervolcano erupts, it doesn't just send lava flowing across the land, it throws the sky into shadow. The ash plume rises higher than any bird can fly, sometimes more than 20 miles up past the clouds into the stratosphere. Up where the wind never stops. There it begins to travel. Ash can move fast, we are carried by winds that circle the globe. Within days, it can fall on countries far from the eruption. A volcano in one corner of the world can hush the skies in another. The earth, in moments like this, feels small and connected. Volcanic ash isn't like the ash from a fire in your hearth. It's not soft or sooty. It's made of tiny fragments of rock and glass, born when magma cools instantly upon contact with air and water, shattering into particles smaller than grains of sand. They are jagged, delicate, and light enough to float for weeks. And as they float, they change the way sunlight reaches the earth. Some ash particles reflect sunlight away, others absorb it. And in large enough quantities, this ash dims the sky, not just directly above the volcano, but around the world. The temperature drops, days feel shorter. Crops struggle, rain falls differently, patterns shift. This effect is called volcanic winter. It's not icy or immediate, it's subtle, a soft, cold hand laid over the shoulders of the world. A kind of planetary sigh drawn from the lungs of the earth and spread like a blanket over all living things. In the past, this ash has written history. There was Tambra in 1815, in Indonesia. The eruption was so vast it produced the year without a summer. In Europe and North America, snow fell in June. Crops failed. Paintings from that year show red skies, eerie twilights, a dimming of the world. People lit lamps at the noon, and behind it all, a cloud of ash. In Iceland, the eruption of Laki in 1783 released not only ash, but gases that poisoned fields, changed the weather, and darkened the skies over Europe. Famine followed. Livestock perished. Some historians believe the unrest it caused helped fuel revolutions. And then, further back, nearly 75,000 years ago, came the eruption of Mount Toba, in what is now Indonesia. A true supervolcano. It filled the sky with ash, cooled the earth by several degrees, and may have caused a bottleneck in human evolution, a sharp decline in population, perhaps down to just a few thousand individuals worldwide. We don't remember these events personally, but the planet does. Ice cores from Greenland and Antarctica hold layers of ancient ash, frozen into the memory of the poles. Tree rings show stunted growth. Lakes preserve the dust at their bottoms. These are the journals of the earth, recording the quiet snowfall of volcanic breath. You lie still now, and imagine the sky above you veiled in grey, the sun softened, the air filled with something ancient, not falling quickly, not violently, but steadily, a reminder that the planet speaks in all directions. And yet, even in this ash, there is not only loss, there is renewal. Volcanic ash, once settled, becomes rich soil. It carries minerals to the land. It feeds forests, nourishes fields. Vineyards in volcanic regions grow grapes with intense flavour. Rice paddies thrive in ash-laced mud. What fell like a shroud becomes with time a gift. Perhaps it is the same in life. Perhaps what falls unexpectedly, what seems dark at first, might one day feed the roots of something new. Ash is not the end of the story. It is the in-between, a quiet turning point. And now, as you rest in your own in-between, not quite asleep, not fully awake, you might feel that too. The way moments settle softly around you. The way thoughts drift like particles. The way quiet can both fall and rise. Close your eyes now and picture that distant eruption. The sky filled not with flame but with memory. Ash, light as breath, circling the world. A slow hush. A different kind of weather. A world not in ruin but in pause. And in that pause a question might gently form, like a shadow on snow. What happens when the sky stays cold? What becomes of the earth when the sun is veiled too long? Next, we'll step into that pause, into the quiet, shivering stillness that follows when the world pauses to shiver. The ash has settled now like dust on a forgotten shelf. The skies remain dim. The air, cooler than it should be, presses gently on the skin of the world. Crops hesitate, leaves curl, even the birds wait, unsure of the seasons. The earth has taken a long breath in and has not yet exhaled. Tonight, you rest in the hush that follows eruption, in the strange stillness that once wrapped the planet, long before memory, before history, before stories written in books. Only stories written in ice and bone remain, faint but lasting, the traces of a time when the world paused to shiver. Our journey tonight takes us back about 75,000 years, to Sumatra in what is now Indonesia, to the Toba supereruption, one of the largest known volcanic events on Earth. It didn't just change a landscape, it changed the climate of the entire planet. You might imagine it unfolding slowly, but the eruption was swift, massive, and unrelenting. The caldera it left behind is now a lake, Lake Toba, wide, blue, and deceptively peaceful. But then, it was a cauldron of unimaginable force. The explosion hurled an estimated 2,800 cubic kilometres of ash and debris into the air, enough to bury a continent. The sky grew thick, sunlight dimmed, and the planet began to cool. Estimates suggest the Earth's average temperature dropped by 3 to 5 degrees Celsius, perhaps more in certain places. This drop may not sound like much, but it meant longer winters, shorter growing seasons, and failed harvests, if humans had been growing crops at the time. But we weren't farmers yet. We were gatherers, wanderers, small bands of Homo sapiens, newly emerged, barely established, and yet somehow we survived. Not all of us. Some evidence suggests that the human population may have dwindled to just a few thousand individuals, perhaps fewer. A genetic bottleneck, a narrowing, like the eye of a needle through which all future generations had to pass. How did we endure? Some scientists believe small pockets of humans, especially in Africa, found refuge near coastlines, where the ocean offered food even in lean years. Others suggest that firelight, community and memory played their part. Warmth shared, stories passed, knowledge kept, and in the ice we find the evidence. Ice cores from Greenland and Antarctica hold layers of volcanic ash from Toba, frozen particles, tiny jagged echoes of that long-ago skyfall. Each layer tells a story of ash, of a cooling, of change. In tree rings, we see years of stunted growth. In sediment, shifts in life patterns. The Earth remembers, even when we forget, and perhaps your body does too. Perhaps somewhere deep in your bones, passed down in tiny messages from ancestors, is a memory of cold, of hunger, of huddling close as shade fell out of season, of the sun's light dulled for days and months and years. You lie still now, but your mind wanders through those ancient winters, not with fear, but with awe, because even in the shadow of Toba, life went on. We adapted, we found warmth, we moved, we remembered, and eventually the sky cleared. The air warmed again. Green returned to grey landscapes, animals migrated, rain fell in rhythm, and the humans who remained began to spread, carrying with them resilience written not just in genes, but in spirit. Toba's eruption was not the end of the world, but it was a deep, cold pause, and in that pause something softened, something awakened. Perhaps it was humility, an early understanding that the earth is not ours to command, that we are small but adaptable, fragile but creative, dependent on a sun that can be muted, carried by a planet that can shake us loose. Tonight, as you listen and drift, you become part of that story. You are the descendant of survivors, of those who weathered the ash, the cold, the silence. Your breath, your heartbeat, your being, all passed through that bottleneck of history, and the earth has paused many times since. There have been other eruptions, smaller perhaps, but still potent. There have been glaciations, droughts, floods, each one pressing gently against life, each one asking the same question, can you endure? And each time the answer has been yes. In that endurance there is quiet beauty, like moss growing on cooled lava, like a seed sprouting in soil enriched by ancient ash. Life doesn't resist change by stopping it, but by folding into it, by yielding just enough to continue. So now, in your own quiet moment, your own night of stillness, you might wonder, what did the world look like when the light returned? What happens after the sky clears and the chill begins to lift? That's where we'll go next, to the places where fire once destroyed, but where life now blooms, to forests reborn in ash, to meadows rooted in ancient scars, to the fire that feeds the forest. The cold has passed, the ash long settled. Somewhere sunlight filters softly through clouded skies once more, and where once there was only silence, there is now birdsong. You lie still, eyes closed, body resting, but your imagination walks slowly through a place reborn. A forest that once stood in the path of molten fire, trees blackened, branches scorched, earth cracked open. But look closely now. There is green among the grey. This is not a scene of ruin. It is a story of return. Volcanoes, when they erupt, reshape more than landscapes. They rewrite life. Their fire clears forests, flattens valleys, buries everything beneath ash and stone. It seems like an ending, swift, absolute, irreversible. But nature doesn't see it that way. Nature waits. In the days after an eruption, the land is quiet. No birds, no insects, no leaves, just heat, steam and stone. But slowly the earth begins again. The first visitors are often the smallest. Mosses, lichens, tiny plants with roots like whispers creeping across lava flows. They don't need much, a crack in the rock, a patch of ash-laced dust. They take hold inch by inch, softening the land. Their presence begins the long work of rebuilding. Their roots hold water. Their leaves draw in light. They die and decompose, and in doing so become soil. From this soil others follow. Grasses, ferns, small shrubs, then trees, their seeds carried by wind and bird. The forest doesn't return all at once, but in waves, a quiet choreography of patience and persistence. Mount St. Helens in Washington state is one of the most studied examples of this rebirth. When it erupted in 1980, it blasted the top off the mountain and flattened everything for miles. Ash buried lakes, lava flowed through valleys. Scientists feared nothing would live there for decades. But just a year later, lupines bloomed. Prairie plants returned. Insects followed. So did birds. Chipmunks. Elk. The land, still warm in places, began to breathe life again. Why? Because volcanic ash, while deadly in its fall, is rich in nutrients. It holds minerals that plants crave: potassium, phosphorus, magnesium. It becomes over time a kind of vitamin for the soil. Like a deep dark mulch, it feeds the forest, not in spite of the fire, but because of it. You can feel this idea settling into you now, like ash settling into the folds of the earth. That something so destructive could also be a source of renewal. It's not just Mount St. Helens. All over the world, life returns to fire-touched lands. In Hawaii, lava fields sprout with ohia trees, their red blossoms bright against the black. In Iceland, volcanic deserts slowly green with moss. In Indonesia, rice grows thick in soil, enriched by eruptions centuries ago. Farmers know this. They build their fields near volcanoes, not out of risk, but hope. The harvests are richer, the grains more plentiful, the fire gives back what it takes, eventually. There is a deep rhythm in this. Destruction, then rebirth. Loss, then life. You might feel it mirrored in your own being. Times when something burned away, and yet, afterward, you grew in places you never expected. You changed. You softened. You returned. Nature doesn't resist this cycle. It leans into it. It trusts that what is taken will become a gift, that what ends will feed the beginning. As you lie there, resting, your thoughts can drift through the forest floor, into the roots of young trees, drinking minerals once hurled into the sky, into the wings of birds nesting where fire once roared, into the soil alive with fungi, insects, microbes, all weaving life from ash. Even the animals have adapted to this rhythm. Some beetles lay their eggs only in burned wood. Certain seeds need fire to crack open. There are frogs who sing louder after the silence. Life listens for the quiet that follows destruction, and knows when to step in. The earth is not sentimental. It does not mourn the loss of trees or the burning of fields, but it remembers. It carries what was lost forward, turning it into something new, something soft, something green, and so the forest rises again. Maybe not in the same place, maybe not in the same shape, but it returns, guided by light, water, time, and the minerals of fire. You too are shaped by forces you may never fully see, by pressures and flames that once moved beneath the surface of your life. But here you are, growing again, breathing, becoming. The Earth teaches us that loss is not always emptiness, sometimes it's preparation. And now, as your breathing slows and your mind drifts like a seed on wind, you might begin to wonder, how do we listen to the land before it burns? How can we hear the warning signs before fire ever rises? Next, we'll explore the tools, quiet instruments and keen eyes that help us measure a giant's pulse. The forest has begun to grow again. The warmth of fire has given way to new green. But beneath it all, beneath the moss, the roots, the hush of birdsong, the earth still stirs, not loudly, not urgently, but with steady breath deep beneath the crust. Tonight you lie still, your body at rest, but your thoughts drift downward again. Not into fire, not into ash, but into listening. Because even sleeping giants have heartbeats. Even supervolcanoes calm on the surface send signals upward. And we, quiet creatures walking on the surface, have learned to listen. Imagine a volcano as a great being lying under blankets of stone. Its movements are slow, its cycles long. But it is never entirely still. It shifts in tiny ways, stretches its limbs in millimeters, sighs in gases and heat. To measure these subtle stirrings, scientists place instruments all around its body, like doctors checking vitals. These instruments do not disturb, they only listen. And through their ears, we begin to understand one of the most important tools is the seismograph. A seismograph listens for earthquakes and tremors that ripple through the earth. Most are too small for us to feel, but magma, when it moves, makes noise. Not the kind of noise we can hear, but vibrations in the rock. As it pushes upward, it cracks stone, shifts chambers, builds pressure. These small earthquakes cluster in patterns that can be read like language. A sudden burst of quakes near a magma chamber might mean movement, a shift in depth, a change in pressure. The volcano speaks, in tremors, not thunder. Next we turn to satellites. High above the Earth, orbiting quietly, satellites measure the shape of the land. They use radar to scan the surface, and they notice things our eyes never would. A hill that has lifted by a few centimeters. A valley that has begun to swell. This is called ground deformation, when the land itself changes shape because of geopressure building beneath. Like the rising of dough under a warm cloth, the Earth swells when magma collects. It may rise just a finger's width in a year, but that's enough to catch a satellite's eye. And from those tiny rises, we begin to feel the heartbeat. There are other tools too. Gas sensors, placed near vents and fissures, measure what escapes into the air. Volcanic gases like sulfur dioxide and carbon dioxide rise when magma nears the surface. Changes in their concentration tell us what's happening deep below. Thermal cameras detect warmth invisible to our skin. Tilt meters measure the angle of the land, alerting us to slight tilts and bulges. GPS stations, rooted firmly in the ground, track every movement with astonishing accuracy. All of these instruments together make up a network, a delicate web of awareness. It doesn't predict eruptions in the way we wish it could, but it gives us clues, patterns, warnings. The volcano doesn't roar in surprise, it murmurs first. And we, if we listen, can hear it. You may be surprised to learn that Yellowstone is one of the most closely monitored volcanoes on Earth. More than 20 seismic stations, dozens of GPS receivers, remote sensing from space. Scientists from around the world keep gentle watch day after day, reading the mountain's quiet messages. They are not waiting for it to erupt. They are watching it live. They are listening to its rhythms, its normal size and shifts, so that one day, if those rhythms change, we will know. You lying here now are part of that listening. Not with instruments, but with attention, with imagination, with the kind of stillness that allows you to hear what isn't shouted. You may feel in this moment the comfort of being observed, not by people, but by the earth itself, by its movements, its changes, slow and ancient language. And in that awareness there is safety. There is no panic in science, only patience, no fear in data, only curiosity. The more we understand a volcano, the less it surprises us. The more we observe, the more we respect. You might imagine now standing at the rim of a quiet caldera, instruments ticking softly nearby, the ground warm beneath your feet. The sky is still. The land hums with time. You're not afraid, you are listening. And that's what it means to live with a sleeping giant, not in denial, not in dread but in relationship, in trust, in balance. Not all volcanoes erupt with warning, but many do. Their patterns shift, their signs grow clearer. Our tools grow more sensitive, our maps more detailed, our understanding more deep. The mountain is not our enemy. It is part of us, part of the living planet that holds our lives in its hands. And now, as your thoughts soften and your breathing mirrors the steady hum of Earth, you might feel yourself gently wondering, what does magma look like when it finally rises? What happens when the heartbeat quickens and the land begins to open? We'll follow that heat, not in fear but in fascination, to the glowing rivers of lava that wind across the surface like veins of fire. The ground has spoken. The pressure has built, shifted, whispered and risen. And now, finally, the warmth that once rested deep below begins its ascent. It does not leap upward. It rises slowly, patient, molten, alive. Tonight, as you lie in stillness, your mind travels with it. Not in fear, but in quiet wonder. You follow the path of magma as it moves through fractured stone, as it pushes through softened rock, as it becomes something new at the surface, lava. The Earth's inner warmth, now visible, now flowing. You're standing, in thought, at the edge of a glowing river. The world is dark, the stars are watching, and before you a thread of orange moves across black stone. It glows not with flame, but with heat, a steady pulsing current of molten rock. This is lava, and it's not what you might expect. It doesn't roar, it doesn't race, it moves with dignity, slowly, thickly, like honey spilled on a tilted plate. It creeps, it pauses, it pools, and all the while it shines from within, a soft inner light, deep orange, gold, red, like the inside of a sleeping ember. Lava is magma that has reached the surface. It is still hot, over 1,000 degrees Celsius, but it is no longer hidden. It is the Earth's truth, poured out in glowing lines. There are different kinds of lava. Some are thick, barely flowing, piling into domes and cliffs. Others are thin and quick, stretching for miles, forming broad, flat plains. In Hawaii, these wide flows are called pahueho, smooth, ropey, gentle, like folds of warm fabric left behind by a giant's hand. Then there is rough, jagged lava that tumbles forward in a chaotic, crunching pile. It's slow but sharp and leaves behind fields that are hard to walk, hard to tame. But whether smooth or sharp, fast or slow, lava does something magical. It changes the land. As it cools, it solidifies, becomes rock. Sometimes it forms glass, obsidian, dark and glistening. Sometimes it cracks into hexagonal patterns, like in Iceland's basalt columns or the Giant's Causeway in Ireland. Sometimes it builds islands, lifts new land from the sea, stone by glowing stone. And where lava flows, new earth is born. You might imagine this now, a coastline growing wave by wave as lava meets ocean. There's steam, yes, a great hiss as fire touches water. But beneath the drama is a calm truth. The world is expanding, the planet is reshaping itself, not with violence but with purpose. Volcanoes like Kilauea in Hawaii erupt not in explosions but in flows. They release pressure in ribbons of fire that slowly trace the land. In their movement, they teach us that not all power is sudden, our strength is steady, some fire is patient. In places like Ethiopia's Erupts or the Democratic Republic of Congo's Nyiragongo, lava lakes swirl within calderas, pools of liquid stone that churn, ripple and breathe. At night they glow against the stars like molten mirrors reflecting the planet's inner life. You might picture one now, a lake but not of water. Its surface is alive, moving, folding, bubbling in slow, silent patterns. No waves, just warmth. A heart open to the sky. It may seem strange to call such places peaceful, but they are. There's something deeply calming about watching lava flow. Its pace is slow, predictable, rhythmic. It's a river that remembers the Earth's beginning. And perhaps your body responds to that memory. To the way heat flows, the way stone becomes soft, then hard again. The way everything changes form but stays part of the whole. Even in destruction, lava is not cruel. It has no intention. It does not choose what to cover, what to spare. It simply follows gravity. It moves. It cools. It becomes. and in time life returns. The first to arrive are often lichens, tiny pale patches clinging to the fresh rock, then moss, then birds, insects, roots, and eventually trees. In Iceland, whole forests have sprung from lava fields. In Hawaii, lava-covered land becomes lush again within decades. The scars heal, the fire becomes soil. You too may carry heat inside and pressures that rise, thoughts that churn, and sometimes they must be released. Not with a shout, not in haste, but with grace, with flow, with the understanding that what rises in you is not dangerous unless denied. Lava shows us how to let go with strength and softness, how to pour out what no longer fits inside, how to cool, how to change. You are watching now as the last of the glowing stream slows. It begins to harden, the shine fades, the surface darkens to grey, then black. The river has become a road, one that other feet may walk, one that life will return to, and in the hush that follows, you feel a question rising like heat beneath stone. Not all eruptions are the same, some shape the land, others shape history. What makes a volcano a supervolcano? What separates the gentle fire from the earth-shaking silence? Next, we'll explore the difference between volcanoes large and small, and what it really means to call one super. The lava has cooled now. The glowing rivers have hardened into stone. What once shimmered with heat now rests in silence, waiting for wind and rain to wear it into something new. And still, deep below the surface, the earth stirs, softly, slowly, shaping futures no one yet sees. You rest here in that quiet, and in this stillness a question forms. What makes some volcanoes ordinary, and others extraordinary? What separates the volcanoes we climb, study, or fear from the ones that can cool the sky? Tonight we explore scale, not just in size but in silence, in potential, in possibility. We compare the fire you can see to the fire that waits, hidden, vast and slow. Let's begin with a typical volcano. Perhaps you picture a conical mountain, steep slopes, a central crater. Mount Fuji, Mount Etna, Mount St. Helens. These are stratovolcanoes, built from layers of hardened lava and ash over thousands of years. Their eruptions may be spectacular, sometimes violent, but they are generally localized. When they erupt, they shape the land around them. They may affect a region, perhaps even disrupt air traffic. But their impact, while dramatic, is limited in space and time. Now imagine something else entirely. A volcano not shaped like a cone, but like a vast bowl. So large you might not even realize you're standing within it. A volcano with no single peak but a sunken, fractured crust. The roof of a giant magma chamber that collapsed under its own weight. This is a supervolcano. It doesn't erupt often. In fact, it may only erupt once every few 100,000 years. But when it does, it doesn't just affect a valley or a mountain range. It alters the planet. The term supervolcano isn't about grandeur or drama. It's about scale, specifically the amount of material ejected during an eruption. On the Volcanic Explosivity Index, or VEI, supervolcanoes sit at level 8, the highest. These eruptions release over 1,000 cubic kilometers of ash and debris. That's enough to bury entire countries in layers of fine grey memory. You might remember Mount Pinatubo, which erupted in the Philippines in 1991. It was a powerful event, classified as VEI 6. It cooled global temperatures by about half a degree for a few years, but the eruption of Yellowstone 640,000 years ago was VEI 8, more than 100 times larger. That is the scale we speak of here. A regular volcano clears its throat. A supervolcano changes the atmosphere, and yet they can look almost the same, or even less dramatic. A volcano may wear its danger on its sleeve. Steaming vents, a tall peak, black rock and fire. A supervolcano hides its power. It may be a gentle valley, a quiet lake, a plain filled with trees. Yellowstone, Toba, Taupo, Long Valley. They are not mountains. They are basins. This makes them harder to spot and more humbling to understand. Supervolcanoes are not more dangerous because they're more active. In fact, they are mostly still. What makes them powerful is the scale of their potential, the sheer amount of energy stored in their subterranean chambers. It's not that they erupt more often, but that when they do, they leave a mark on the world itself. They change climates, they test ecosystems, they press gently against the edge of survival, but they also teach us. They show us what pressure, when held for millennia, can do, what silence can contain, what stillness may one day release. and they teach us to listen, to look, to measure the Earth, not by what we can see in a moment, but by what we can imagine across eons. You might wonder now, how does one build such a giant? It starts with a hotspot or subduction zone, a place where magma collects beneath the crust. Over tens of thousands of years, that magma accumulates. It doesn't always escape in small eruptions. Sometimes it remains trapped, rising slowly, building pressure. The crust begins to bulge gently. The ground lifts. Earthquakes flicker through the rock. Gases seep upward. And then, one day perhaps, the chamber ruptures. When a supervolcano erupts, it is not a cone that blows off. It is the land itself collapsing inward. The roof of the magma chamber falls, releasing the built-up pressure in a cascade of fire and ash. The eruption can last days or weeks. The effects can last centuries. And then, it sleeps again. For all their magnitude, supervolcanoes spend most of their lives in dormancy. Quiet. Unseen. Their power is not in movement, but in stillness. You lie here now wrapped in that idea. That scale is not always noisy. That greatness is not always visible. That a sleeping thing may hold more strength than a roaring one. And still the Earth carries both. The frequent flare of smaller eruptions, the rare breath of giants. Each has its place. Each shapes the world in its own way. Your own thoughts too have scales. Some rise quickly and fade, sparks of imagination, flickers of insight. Others rest deep below, forming over time, growing quietly, holding heat. They shape you even when you don't notice, even when they seem to sleep. Tonight, as you listen, you may begin to feel that truth within yourself. That power doesn't always rush. That transformation may wait beneath the surface, slow and deep. And just as Earth builds these chambers of fire over thousands of years, so too do we build meaning, patience, understanding. One quiet layer at a time. The mountain doesn't have to move. The change may already be happening inside. And now, as your mind slows to match the rhythm of this sleeping power, a new thought forms, soft as a rising breath. What fuels a fire that never fully goes out? What keeps a hot spot burning beneath the same patch of sky for millions of years? Next, we follow that trail to the slow, smouldering path of heat that creates volcano after volcano, even when everything above seems still. You rest now in the slow breath of the planet, in the hush of stone shaped by invisible heat. The last chapter left you on the edge of magnitude, standing in wonder before the sleeping giants of the Earth. And now, in this quiet space, we follow the source of that power, the slow, steady flame that never goes out. Tonight, we drift with a hotspot, a name that sounds simple, even small, but holds within it the warmth that reshapes continents. A hotspot is not a place exactly. It is a presence, a column of heat that rises from deep within the Earth's mantle, not from the shifting edges of plates, where earthquakes dance and volcanoes frequently burst, but from the middle of things. Quiet zones, places that seem on the surface completely still. And yet, beneath them, a flame burns, unmoved by time, undisturbed by tectonic fuss. It's not a fire in the usual sense. There are no sparks, no dancing flames. This is mantle plume, a slow uprising of deep heat, travelling upward like smoke that no wind can scatter. You might imagine it now, a narrow thread of warmth rising from the deep earth, glowing softly, gently melting rock above it. It touches the base of the crust, and there, if the crust is thin enough, a volcano is born, not once, but many times, because the hotspot stays still, and the earth moves. This is the secret of hotspots. The heat doesn't drift, the land does. The tectonic plates of the earth float on the mantle like enormous rafts. As a plate slowly moves, inch by inch, year by year, it carries the surface across the steady plume of heat. And each time a new section of the crust passes over the hotspot, new magma rises, new land forms, and a new volcano begins. This is how the Hawaiian Islands were made. They did not rise all at once like a single mountain. They were built in a line, one after another, each born from the same patient breath of heat, each left behind as the plate moved northwest. The youngest, Hawaii, or the Big Island, still sits above the hotspot. It still grows, lava flowing, land forming. The older islands, Maui, Oahu, Kauai, have drifted off the hotspot and grown quieter with time, like echoes fading into distance. You might think of the islands now as beads on a string, each one cooled from the same source, a volcanic family stretching across the Pacific, and beneath them, stiller, that slow column of warmth endures. Hotspots exist in other places too. In Iceland, where the plume rises beneath a mid-ocean ridge, feeding both fire and spreading plates. In the Galapagos, where lava forms lands that inspired Darwin. And beneath Yellowstone, yes, even here, a hotspot simmers, shaping valleys and heating the land from below. Some scientists believe Yellowstone's hotspot has left tracks across the American West, like glowing footprints. As the North American plate drifted southwest over millions of years, it passed over that stationary plume, and with each crossing a caldera was born. The scars are still visible if you know how to look. It's humbling to think that what seems fixed, the land beneath your feet, is always in motion. That a single breath of heat rising endlessly from deep inside the planet could leave mountains and lakes in its wake. Hotspots move through time, not space. They are stories written in volcanic ink, each chapter tens of millions of years apart. And still, they persist. You listening now may begin to feel that same sense of quiet endurance in yourself. Something that doesn't flash brightly but burns steadily. A warmth that doesn't demand attention but creates with time. Patience is its own kind of power. Hotspots don't announce themselves. They are discovered through patterns. Trails of volcanoes, chains of islands, subtle ground uplift, gases that rise, heat that flows. We find them not because they burst, but because they linger. In a world that moves quickly, erupts suddenly, and changes without warning, there is something deeply comforting about the idea of a hotspot, a constant presence creating land slowly and generously, without need for praise or recognition. Some hotspots may eventually fade, others may shift, but their mark remains. Long after last eruption, the land they made continues to hold life. The soil becomes fertile, rain falls, plants root, animals walk across cooled lava, people settle, a volcanic island becomes a home, and perhaps in a way, so do you. Not every change has to be dramatic. Some transformations begin deep within, with a warmth that builds over time, a thought, a dream, a feeling. You don't need to erupt to become something new. You only need to rise solely from the centre of yourself. That's what a hotspot teaches us. It teaches us how to be steady in a world of movement, how to create without rushing, how to trust in the slow fire. And now, as your breath grows slower, your mind warm and quiet, you may feel a new question beginning to form, a gentle curiosity flickering on the edge of thought. Where has the Earth recorded all of this? Where are the journals, the pages, the memories of fire? Next we'll uncover them, in layers of rock, in frozen cores, in the ancient stone that holds the Earth's autobiography, the history written in stone. You're resting now, wrapped in silence, but beneath your quiet the Earth is remembering, always remembering. It keeps no books, no songs, no spoken tales. Its memory is deeper, pressed into stone, folded into layers, written in the hardened breath of time. Tonight you and I will read from that memory, gently, like turning the pages of an ancient diary, worn smooth from age, yet rich with detail. A story written not in words but in minerals, in lines, in pressure. A history written in stone. You may not think of rocks as storytellers, but they are. Every cliff face, every canyon wall, every layered slope by the side of the road is a library. Each stratum and each band of colour and texture is a chapter, pressed flat by time and the weight of all that came after. We begin with the oldest pages. Deep beneath the surface, igneous rocks, rocks born from fire, tell us where magma once moved. Granite, obsidian, basalt. These are the cooled remains of ancient eruptions. Their crystals grow at different speeds depending on how quickly the lava cooled. Large crystals mean slow cooling, deep inside the earth. Glassy surfaces mean quick cooling at the surface, in the air. Hold a piece of obsidian in your mind. Smooth, black, reflective. This is frozen lava turned to glass in an instant. A snapshot of a volcanic breath. Then there are the sedimentary rocks, the ones that form not from heat, but from dust and water. From the settling of particles over millennia. Ash from a long ago eruption might drift across a continent, settle in lakes, mix with rain. Over time it hardens into tough, pale, soft stone that holds the fingerprint of a distant eruption. And finally, metamorphic rocks formed under heat and pressure, reshaped into something new. These are the erased and rewritten pages, the ones that show where the Earth's crust was folded, buried, changed. Even in transformation, the story remains. Scientists, geologists, volcanologists, paleoclimatologists learn to read these pages. They use tools to slice into stone cores, to map cliffs, to peer inside mountains. They look for ash layers, mineral shifts, trapped bubbles of gas. Each discovery becomes a sentence, a paragraph, a timeline. Imagine now a thin core of rock, about the width of your wrist, lifted from deep beneath the Earth's surface. It's a cylinder of history. At the top, recent soil. Beneath that, compacted sediments, pressed over centuries. And deeper still, a band of grey, a thin, distinctive layer of volcanic ash. That ash tells a story. Maybe it came from Mount Mazama, which collapsed into Oregon's Crater Lake nearly 8,000 years ago. Or perhaps it's the distant fingerprint of Toba, 75,000 years ago. It's ash having travelled halfway around the world. Maybe it belongs to a forgotten eruption, one not recorded in any myth or memory, but preserved here in stone. The ash layers act like bookmarks in time. We find them not only in rocks, but in ice, in the frozen cores pulled from Antarctica and Greenland. There too are the stories. Layers of snow turn to ice year after year, like tree rings, holding tiny bubbles of atmosphere and fine particles of volcanic glass. The Earth keeps all its memories. You may not see them when you walk the ground, but every mountain once rose from pressure. Every valley once held water. Every stone beneath your feet has felt fire or frost, has waded, has changed. And even now the process continues. New layers form, new ash falls. Rivers carve stories into canyons. Lava writes bold lines across the land. The journal is never closed. You, resting here, are part of that record too. The calcium in your bones, the iron in your blood, the silica in your cells, these come from stone. From the minerals laid down in the Earth's long remembering. You carry within you pieces of ancient mountains, echoes of eruptions long past, ash reborn into thought, into feeling, into breath. It's comforting in a way, to know that even destruction leaves a trace, that even after fire, after flood, after collapse, something remains. Something solid, something that waits to be read. Perhaps that's what memory truly is. Not perfect reshape, but presence. Not a full story, but enough of one to build the next. The rocks don't tell her everything. They don't reveal every detail of how it felt to live through those moments. But they give us shape, sequence, the rhythm of the world in layers. And so we listen. We walk slowly through canyons. We run fingers across ancient stones. We study the past, not to fear the future, but to understand it. To feel the continuity of it all, the way the Earth keeps writing no matter what. And you tonight are reading that story with your breath. Each inhale, a turning page. Each exhale, a moment of comprehension. You're not just observing the planet, you're of it. As your thoughts soften now, you might picture yourself lying on warm stone, not sharp but smooth, sunlit, wrapped in the hush of old winds. Beneath you are centuries pressed together, sleeping in sequence. Around you, silence shaped by time, and gently you begin to wonder. What happens when fire meets not land, but ice? What stories are written beneath the glaciers, where the heat still rises? Next we'll travel to those secret places, where volcanoes sleep beneath ancient ice, and where two opposites hold each other in delicate, trembling balance. You are lying still now, wrapped in warmth, in rhythm, in the gentle memory of stone. But the Earth, always turning, always surprising, offers another paradox to explore, another quiet contradiction to carry into sleep. Tonight, we travel where opposites meet. To the places where fire burns beneath frozen silence. To volcanoes that sleep beneath glaciers and sometimes wake. Picture a mountain, covered in ice. Not snow, but thick, ancient ice, blue-tinged and heavy, layered for centuries. It presses down with unimaginable weight, carved by time, smoothed by wind. The landscape looks timeless, motionless, but beneath the ice, something stirs. A volcano, not roaring, not erupting, just breathing, slowly. Its heat rises upward, Melting ice from below, cracks form, caverns open, water trickles through ice that seems eternal. This is subglacial volcanism, one of the Earth's most fascinating dances. Fire and ice sharing space, neither defeating the other, each shaping the land in its own quiet way. Iceland is one of the best-known stages for this performance. Here, glaciers cover volcanoes like Vatnajökull, hiding some of the most active systems on Earth. Underneath the icy surface, magma occasionally rises. Sometimes it never reaches the air, it melts the ice above it, then settles. Other times it erupts. But when a volcano erupts beneath a glacier, it doesn't look like the towering fountains of Hawaii or the explosive ash clouds of Mount St. Helens. Instead, the eruption is muffled, contained. The heat meets the ice in an instant, and the result is steam. Vast, pressurized clouds of steam. Imagine for a moment magma pushing into the base of a glacier. The ice above begins to melt rapidly, forming pockets of water, lakes beneath the glacier hidden from view. These lakes grow quietly, they deepen, and when the pressure becomes too great, they burst. These floods are called Jökulhlaups, an Icelandic word for glacier outburst floods. They arrive suddenly. Water pours from beneath the ice, carrying debris, rock, even entire chunks of ice. Rivers swell, plains flood, and then, just as suddenly it's over, the glacier settles again. The land returns to quiet. But it's not just Iceland. In Antarctica, volcanoes like Mount Erebus rise beneath the thickest ice on the planet. There too, warmth bubbles upward, forming meltwater streams under the frozen surface. Some scientists even believe that subglacial volcanism may influence the rate at which Antarctic ice melts, a hidden contributor to sea level rise. Even in Greenland, there is evidence of fire beneath the ice sheet. The two forces, long imagined as opposites, are often neighbours. It's a beautiful tension, this balance of heat and cold, and it reminds us that the Earth is not built of simple opposites. It is made of relationships. Fire does not always destroy ice. Sometimes it shapes it, melts it just enough to carve channels, to shift the glacier's course. And ice does not always smother fire. Sometimes it gives it form, controlling its shape, cooling its flow, forcing it to create rather than erupt. The mountains formed by subglacial eruptions are unlike any other. They are called tuyas, flat-topped, steep-sided formations made when lava erupts into a lake of melting glacial water. The lava cools quickly, shaping unique columns, ridges, and shelves. When the ice eventually retreats, the tuya remains, a frozen moment in geology, preserved in basalt. Imagine lying at the base of one now, the wind sweeping gently across your face, the stone beneath you warm from sunlight. You feel the story in the rock, a moment when fire met ice and neither one won. Instead, they made something new. There's something deeply human in that. We often think in binaries, hot or cold, still or moving, peaceful or violent. But the Earth is more nuanced, more gentle. It allows contradictions to coexist. It allows tension to create beauty, and perhaps we can do the same. You are made of warmth, your body, your thoughts, your breath. But you hold coolness too, the calm of reflection, the hush of sleep, the slow drift into dreams. Within you fire and ice meet and balance. As you breathe now, slowly, deeply, imagine that meeting within you, not in conflict but in harmony. The slow warmth of your centre, the cool stillness of your surface, they shape you together. Even in Thailand's volcanoes beneath glaciers are shaping the world. Not loudly, not quickly, but steadily. Their meltwater carves valleys. Their heat creates hidden rivers. Their eruptions change the sky, if only briefly, in bursts of steam and scattered ash. We don't always see it, but we can feel it. Like intuition, like memory, like dreams. And so, the story of fire and ice becomes a lullaby, a song of patience and power. Now, as you drift further into rest, wrapped in the gentle paradox of flame beneath frost, you might begin to wonder, what sound does the Earth make before it wakes? If volcanoes can speak, what language do they use? Next, we'll listen more closely to the quiet murmurs before an eruption, to the deep notes beneath our feet, and to the strange music of a mountain before it rises. You're resting now, warm and still, suspended in that soft space between thoughts, but the Earth is never completely quiet. It hums, it pulses, it sings, not with melody, but with movement. Tonight we listen, not for the crash of eruption, not for the thunder of ash or the roar of fire, but for what comes before, the whispers, the murmurs, the subtle sound a volcano makes before it wakes. Because yes, volcanoes have a voice. You may not hear it with your ears, but the earth speaks in waves, sound waves, pressure waves, deep vibrations that travel through stone and sky. These signals, too low for human hearing, are called infrasound. They vibrate at frequencies below 20 Hz, deeper than a whale's song, slower than the rhythm of a drum. The sounds of volcanoes are part of this subterranean language. They begin long before eruption, and if we learn to listen, we begin to understand. Imagine now, standing at the foot of a slumbering volcano. The wind is gentle, the trees still, but somewhere beneath your feet something begins. A slow rumble, a pulse of pressure. Not a boom, not a quake, but a tremor. Repeating, steady, like a low note held for minutes at a time. Scientists call this a harmonic tremor. It's one of the earliest signs. It happens when magma begins to rise, forcing its way upward through narrow conduits in the crust. As it moves, it vibrates the surrounding rock. These vibrations are rhythmic, sustained, and musical in a way. Not chaotic like earthquakes, but smooth, even hypnotic. They are the mountain's breath before a word is spoken, and they can last for hours, even days. Alongside tremors, there are pressure waves. Small explosions of gas within the volcanic system, carbon dioxide, sulfur dioxide, water vapor. Each release adds to the song, a pop, a hiss, a surge. Infrasound sensors placed carefully around volcanoes can detect these bursts from miles away. To us, the mountain seems silent, but to the instruments it is alive with voice. You might think of it as a kind of symphony. Magma's motion as the cello, deep and resonant. Gas emissions like violins, soft and sharp, earthquakes like the drum beats beneath it all. And above, the crust stretching, flexing, preparing, a full orchestra hidden beneath the ground. In 2010, scientists listening to Iceland's Eyjafjallajökull volcano noticed an increase in harmonic tremors and infrasound days before it erupted. The volcano, though mostly quiet to the ear, had been humming its intent, gently, insistently. When the ash finally reached the sky, the warning had long since been sung. Not all eruptions give such elegant notice, but many do, and just as a storm carries a scent before it arrives, a volcano sends its sound ahead like a shadow. There's something deeply poetic in that. Not all warnings must shout. Some hum, some whisper in frequencies we must learn to feel, not hear. And some we only notice in retrospect, like realizing a lullaby had been playing all along. Tonight, as you lie still, you may begin to imagine this sound. Not as noise, but as vibration. A slow, deep thrum beneath your ribs. A note so low it feels like gravity itself. That's what infrasound does. It's not something you hear, but something you sense. Birds and animals often detect these signals long before humans do. In some places, elephants grow restless days before a volcanic eruption. Birds take flight without reason. Herds move. Infrasound moves freely through the air and ground, travelling farther than any shout. Nature listens, even when we forget how, but now, we're learning again. Scientists use arrays of sensors, small, precise microphones tuned to the lowest registers, to detect and map infrasound. They use computers to visualize the patterns, to see the music in waveform. Each volcano has its own signature, its own song. Like voices, no two are the same, and just as lullabies vary in tone and rhythm, so do these geological melodies. Some volcanoes hum gently for weeks, others grow quiet just before an eruption. Some sing in bursts, others in slow, continuous chords. To listen is to know, and knowledge brings peace, not because it erases risk, but because it prepares us. There's comfort in knowing that the earth rarely surprises us without warning, that it speaks, that we can listen. And perhaps you right now are listening in your own way, to your own inner tremors, to thoughts rising slowly through the quiet, to the breath that moves through you like a wave of warm air. Your body too has its harmonies, its own low music, a heartbeat, a rhythm, a knowing. You are part of the same earth that hums beneath volcanoes, the same minerals, the same elements, the same silent language of heat and time. And so as you drift deeper into sleep, you may feel a closeness to this idea, that before even the most powerful moments, there is a quiet, a preparation, a sound only the still can hear. And as you rest in that stillness, you may find yourself wondering, when ash reaches the sky, what does it do to the air itself? What happens when fire not only reshapes land, but also paints the atmosphere? Next we rise upward, following the plume, to the sky gardens formed by ash, and to the delicate dance between volcanoes and the air we breathe. The ground has grown quiet again, the harmonic tremors have faded, and now in your resting breath we drift upward, not down into magma chambers, not across blackened fields, but into the sky itself, because volcanoes don't end at the surface. Their stories stretch far beyond the stone. Tonight we rise with the ash. You lie still, your body soft and slow, and yet your thoughts are weightless. Imagine now that you are a single particle of ash, lifted from the earth in a great eruption, light enough to float, small enough to ride the wind. You spiral upward, caught in invisible currents, rising past the clouds, higher than any bird, higher than any storm. You reach the stratosphere. Up here the air is thin, dry and cold. There is no weather as we know it, no rain, no snow, only the steady circling winds that move around the planet. And here you drift, not for hours, but for weeks, sometimes months, sometimes years. Volcanic ash in the stratosphere is not just dust, it is memory, suspended. Along with it come gases, especially sulfur dioxide. Released in vast quantities during major eruptions, sulfur dioxide combines with water vapour high in the atmosphere to form tiny droplets of sulfuric acid. These droplets scatter sunlight. The result is a dimming of the Earth's light. Not complete darkness, not an eclipse, but a soft veil over the sun, a shift in tone, a cooling in the air. Temperatures drop by fractions of degrees that echo through ecosystems, seasons, even human history. This process has happened again and again. In 1991, Mount Pinatubo erupted in the Philippines, sending a column of ash and gas over 35 kilometers into the sky. Within weeks, a sulfuric haze encircled the globe. Global temperatures dropped by about 0.5 degrees over the following year. Sunsets deepened into reds and purples. The world dimmed gently, noticeably. In 1883, Krakatoa's eruption in Indonesia painted skies so vividly that artists tried to capture them in oils and watercolours. Edvard Munch's The Scream, some believe, was inspired by the surreal red sky seen after a volcanic haze swept over Europe. And in 1815, Mount Tambora's massive eruption created the year without a summer. Ash and aerosols cooled the planet, led to failed harvests, food shortages, and a strange unseasonal chill that wrapped itself around the globe. This is the reach of volcanoes. They do not simply break mountains or build islands, they touch the clouds, shift the air and sketch new patterns in light. And in doing so, they also give. Volcanic ash, though it may seem destructive, can nourish the sky and sea alike. When fine ash settles into oceans, it brings with it trace minerals like iron. In certain areas, this iron acts as fertilizer for phytoplankton, the tiny floating plants that form the base of the marine food web and produce much of the world's oxygen. A single eruption in the right place can lead to a bloom, a sudden flowering of life across the sea's surface. Green clouds of phytoplankton stretch for miles, feeding fish, absorbing carbon dioxide, and exhaling fresh oxygen into the sky. Even from the chaos of eruption, balance returns. Some scientists are even exploring whether mimicking this process, adding iron to ocean waters, could help combat climate change. The Earth has been doing it naturally for millions of years. Volcanoes remind us that destruction and creation are not opposites. They are partners. The sky too remembers. Satellite images capture the swirling patterns of ash plumes, curling like smoke across continents. Pilots chart their routes around them. Animals adjust migration. Plants sense the light change. We feel the air grow cooler, crisper, laced with something ancient. And above all, we see beauty. Sunsets become more vivid after eruptions, the sky painted in layers of pink, violet, deep gold. The ash and aerosols scatter light differently, extending the colours, sharpening the contrast. The horizon becomes a canvas coloured by the memory of fire. It's hard not to see poetry in that. From the mouth of a volcano comes a sky transformed. From the Earth's darkest breath, a masterpiece in light. And as you lie here, letting this idea drift through you like dusk, you may begin to feel it. The deep connection between land and air, the invisible threads that tie soil to sky, stone to star. You are made of earth, yes, but you breathe sky. The air in your lungs tonight may have circled the globe. It may carry molecules born in ocean blooms, or cooled by ash that once floated above the Andes, or touched by sulphur spun from a Pacific fire. We are not separated from the atmosphere. We move within it. And volcanoes, though they live in stone, speak most clearly through the air. Their ash feeds clouds. Their heat stirs winds. Their silence, once broken, paints light across the heavens. And perhaps the sky, in its changing colours, remembers each eruption not as tragedy but as transformation. Not as an ending, but a moment of balance, of motion, of breath. You, now drifting in that breath, may wonder, where does this dance of gases and fire begin? Not just the eruption, but the chemistry. The invisible alchemy that takes place deep below before anything ever reaches the surface. Next we descend again, into the bubbling, reactive world where rocks melt, gases swirl and eruptions are born in elements, the chemistry of an eruption, and the secrets it tells. You are quiet now, floating gently at the edge of sleep, where thoughts dissolve like mist. You've journeyed into ash-filled skies, watched lava draw red lines across stone, and listened to the mountain's low hum, but now we go deeper, not just into the earth, but into the fabric of what stirs it. Because every eruption begins not with thunder, but with chemistry. Tonight, we wander into the slow and silent laboratory beneath your feet, where pressure, heat and elements mix in dark chambers. Where reactions happen not in seconds, but in centuries. Where magma brews like a potion, gathering all the ingredients it needs to become a voice of fire. It begins with melting. Deep beneath the crust, temperatures climb. Water from ancient oceans, drawn down by shifting tectonic plates, slips into rock and lowers its melting point. Minerals loosen, crystals dissolve, and what was once solid begins to flow slowly, thickly, into magma. But magma is not one single thing. It's a mixture, a blend of molten rock, crystals and dissolved gases. Its recipe varies from place to place, and every variation changes how it moves, how it cools, how it erupts. Silica, for example, the same compound found in sand and glass, is a key ingredient. The more silica in the magma, the thicker it becomes. High silica magma, like rhyolite, moves slowly, traps gas, and often leads to explosive eruptions. Low silica magma, like basalt, flows more freely, often creating gentle lava streams. So a volcano's behaviour is shaped by what lies within, by its chemistry. And chemistry, at its heart, is about relationships. In the bubbling magma chamber, atoms and molecules move and shift. Oxygen bonds with silicon, iron with oxygen, gases like water vapour, carbon dioxide and sulphur dioxide dissolve under pressure, like fizz trapped inside a sealed soda bottle. But as magma rises, pressure drops, and that's when the real magic begins. The gases begin to escape, exsolving, scientists say, like bubbles forming in champagne as the cork is popped. These bubbles grow rapidly, expanding within the magma. If the magma is thick, the gas cannot escape easily. It builds, it strains, it creates tension, until it bursts. That bursting is the eruption. The moment when chemistry becomes action. When a formula becomes a flame, you might think of it like baking bread. The yeast, like gas in magma, creates bubbles. In a soft, flexible dough, they rise easily. But if the dough is too tight, the pressure builds unevenly. The bread might crack or even explode in the oven. Volcanoes are no different. Their eruptions are chemical reactions, shaped by ingredients, timing and heat. Some volcanoes are sulphur-rich. Their gases sting the air, form acid rain, influence clouds. Others release more carbon dioxide, the same gas you exhale, the one that shapes climate and breathes life into plants. Still others release fluorine or chlorine, trace elements that can influence ecosystems far away. The exact chemistry of a magma body tells us not only how a volcano might erupt, but what legacy it might leave behind. In ancient times, people saw eruptions as the anger of gods, unpredictable, unstoppable. But now, with microscopes and mass spectrometers, We look at tiny inclusions, bubbles frozen in crystals, droplets of ancient melt, and we see intention, not emotion, not rage, but logic, patterns, processes, equations. An eruption is not random, it's a culmination of temperature, of composition, of timing. Even the colours of lava tell stories. Bright orange signals high temperatures, around 100 degrees. Duller reds mean cooler flows. The black crust of cooling lava crackles and folds, a skin forming over molten thought. Each eruption is a statement in the Earth's language of heat, and like any language, it can be learned. Scientists now experiment with synthetic magma in labs, heating rock powders, watching how bubbles form, how crystals grow. They track the behaviour of gases, the viscosity of melts, the chain reactions that turn potential into eruption. These experiments are quiet, careful, and deeply poetic. They mirror the slow drama happening miles below us, a chemistry older than language, older than life. And while we may never predict every eruption, we can begin to understand their patterns, their rules, their personalities. Because every volcano is different. Some are quick to rise, releasing pressure through frequent flows. Others wait. They gather. Their chambers evolve. Gases accumulate, crystals grow. When they finally erupt, the blast is shaped by years, even centuries, of slow chemical thought. You, lying here, are part of this system. Your body is made of these same elements: oxygen, silicon, carbon, iron. Your breath carries carbon dioxide. Your bones carry calcium from ancient seas. You are chemistry in motion, balanced delicately, reacting gently to warmth, light, and thought. And maybe tonight, as you drift into rest, you feel a kinship with that underground laboratory. Not because of fire or pressure, but because of process. You too are shaped by the quiet reactions, by slow changes, by relationships between things unseen. And in those shifts, in those tiny moments of transformation, there is wonder. The mountain doesn't need to roar to teach us. It only needs to brew, to hold, to balance. And as your mind begins to quiet now, soft as cooling lava, a final question begins to form. What stories do we tell about fire when we cannot see the chemistry? What wisdom did the ancients pass down, not through instruments, but through stories, myths, and memory? We'll listen to the oldest storytellers, the humans who watched fire rise, who gave it names, who shaped it into gods and symbols, and whose voices still echo in the flicker of flame. The laboratory of the Earth is quiet now, its gases cooled, its minerals settled, its reactions paused in stone. But long before we had the tools to measure magma's chemistry, long before the words lava, ash plume, or volcanic winter existed, people still watched the fire rise. They saw it, smelled it, felt it in the ground beneath their bare feet. And they remembered. Tonight, we leave behind graphs and instruments. We walk softly into stories, into the glow of campfires, into the words spoken under stars passed from mouth to ear for generations. We enter the oldest archive, the human memory, because volcanoes are not only geological features, they are characters, beings, teachers. Long before science there was story, and stories hold truth too. You are lying still, eyes closed, breath deep and slow. But your thoughts move now across time and ocean back to when knowledge was shared through song, gesture, and flame light. In Hawaii, Pele is the goddess of volcanoes and fire. She is both creator and destroyer. Her home is in Halemaumau crater at the summit of Kilauea, where lava glows beneath the surface. According to Hawaiian tradition, she journeys through the islands, shaping the land sometimes in anger, sometimes in love. When lava flowed down toward villages, people left offerings, flowers, food, chants, not in fear but in respect, because Pele was not just an explanation. She was part of the land, a reminder that the earth is alive, that it feels, that it responds. And in a way that is true. Volcanoes are not random. They move with patterns, with rhythm. They give signs, tremors, smoke, steam. Indigenous peoples, watching carefully, learned to interpret these signs. They remembered which birds flew away before eruptions. They listened to the mountain's voice long before microphones existed. In the Pacific Northwest of the United States, the Cowlitz and Yakima peoples told stories of two great spirits, Luvwitlatkla, the fire woman, and the feuding brothers Waiist and Klikaitat, whose battles shook the earth and shaped the Cascade Mountains. Mount St. Helens, known as Lewitt, was the beautiful maiden whose heartache led to the mountain's shattered shape. And indeed, in 1980 she erupted violently, reshaping the landscape just as the story had described, fire following heartbreak. In Indonesia, one of the most volcanically active places on Earth, communities have long viewed eruptions as a conversation between the gods and the people. Mount Merapi, whose name means mountain of fire, is both feared and revered. Offerings are still made to appease its spirit, and in recent years, scientists and spiritual guardians have begun working together, blending data and tradition. You might think of these stories as fiction, but pause, because many of these oral traditions have preserved surprising accuracy over millennia. Stories passed down in Aboriginal Australian communities describe coastal flooding, volcanic activity, and changing landscapes, events that geological evidence dates back 7,000 to 10,000 years. Descriptions of lava fields, ash fall, and ground shaking that have been told for so long they predate written language, yet align closely with what science has since confirmed. These aren't just metaphors, they are memory. Memory wrapped in meaning, and meaning wrapped in myth. You tonight are part of this lineage of listening, not to machines, but to Earth itself, and to the people who listened before you, who lived near volcanoes and knew how to read them through birdsong, through cloud shape, through the tension in the air before the ash fell. There is wisdom in watching, and there is kindness in sharing. That's what these stories did. They taught, they warned, they comforted, they reminded communities that fire may rise again, and that together we survive not just through technology but through care, through listening, through storytelling. You may picture a circle of people now sitting by a fire. The night is cold, the wind moves through tall grass. The mountain looms in the distance, quiet for now. Someone, an elder, a parent, a child who learned it yesterday, begins to speak. A story unfolds, and within that story the memory of eruption, the lesson of ash, the patience of the land. It is not a textbook. It is not exact. But it lives. And as it lives, it protects. There is something sacred in that, in the idea that science and story do not stand apart, that they walk side by side, that measuring ash and honouring gods can both lead to understanding, that we, with all our satellites and sensors, are still shaped by the desire to explain, to make meaning of trembling ground and glowing stone. And meaning takes many forms. You, now resting beneath your own roof, far from the crack of eruption, may still carry questions. What would it feel like to live beside such power? What would it mean to raise your children in the shadow of a smoking peak? For many indigenous peoples it means respect, not fear, not conquest, but reverence. The volcano is not an enemy. It is an ancestor, a guardian, a force to be watched, to be honoured, to be lived with, not against. And perhaps that's what we can learn, even now, that danger doesn't always demand domination, that some powers must be partnered with, not solved, that the Earth speaks in many voices, some in data, some in legend, and each deserves to be heard. So as your breath deepens and your thoughts begin to quiet, you may feel a warmth not just from beneath the earth, but from those who came before, the storytellers, the watchers, the quiet listeners of stone. Their voices still echo, in myths, in chants, in the very shape of the land. And softly, a final question drifts through your mind. In our world of sensors and models, how do we prepare for what may never come? What does it mean to plan for a supervolcano that might sleep for another 1,000 years? Next we step into the future, into the quiet discipline of readiness, into the maps and drills and steady hands of those who prepare for tomorrow's fire, even if it never arrives. You are resting again, gently held by sleep's edge, where thoughts loosen and stretch like slow clouds. We've wandered through myths and memories, through fire and stone, and now we arrive at a place of stillness, not the silence of forgetting, but the stillness of waiting. Tonight we explore readiness, not the alarmed, breathless kind, but a calm, deliberate watching, a discipline shaped by science, wisdom, and hope. Because some volcanoes, the largest of all, sleep so long between eruptions that their danger can feel abstract, almost mythical. These are the supervolcanoes, the ones whose awakening would ripple across skies and seasons, the ones we study not because they are likely to erupt tomorrow, but because if they do, the world will change. And so we prepare, slowly, steadily, like the Earth itself. To prepare for a supervolcano is to work with possibility, not certainty. It begins with maps, vast, colourful models of underground magma systems. Scientists use satellites to measure how land swells, even by a centimetre, as magma shifts below. They use GPS, infrasound, thermal imaging. They listen for tremors, watch gas emissions, track every small breath the volcano takes. Places like Yellowstone in the US, Lake Toba in Indonesia, and the Taupo region in New Zealand are watched constantly. Each is a known supervolcano, each with a long and powerful past. Yellowstone especially stirs the public imagination. But scientists remind us, it shows no signs of imminent eruption. Still, beneath its geysers and hot springs lies a massive magma chamber. It breathes, it shifts, it warms the ground from below, and so it is studied, not with fear but with focus. Emergency planners run simulations. They model how ash might spread across continents, how air traffic would be grounded, how agriculture would be disrupted. They ask, where would the ash fall? How deep would it gather? What happens to crops, to water, to lungs? Hospitals, cities, and agencies have drills, just in case. Ash masks are stockpiled, communication systems tested. Scientists refine eruption forecasts, combining geophysical data with statistical models. And while the probability of a supervolcano erupting in our lifetime remains small, the potential impact is large enough to earn our attention. Because readiness isn't about panic, it's about compassion. It's about knowing that our choices, made in quiet years, shape how we respond in noisy ones. And readiness doesn't live only in laboratories. It lives in schools, where children practice drills not to be frightened, but to understand. It lives in local governments, in scientists' notebooks, in international collaborations that share data across borders. Because volcanoes don't care about maps. Their ash crosses oceans. Their effects are global. A supervolcano might lower temperatures across the planet by several degrees for months, even years. Crops might fail in distant countries. Rain patterns could shift, the sky might grow dim with aerosols, painting sunrises with unnatural fire. And yet life would go on, because we prepare. We learn from smaller eruptions. From the Eyjafjallajökull eruption in 2010, we learned how quickly air traffic can be disrupted, and how to better track ash clouds. From Pinatubo in 1991, we saw how eruptions affect climate, and how models can help save lives. Over 75,000 people were evacuated before Pinatubo's blast thanks to early warnings. And from those older stories, Krakatoa, Tambora, even the myths of Pele and Luit, we remember how memory becomes our best teacher. You lying here are part of this lineage of awareness. Even in sleep your body prepares, healing, restoring, resetting. Your immune system scans, your cells renew. This is your own kind of readiness, not rushed, not alarmed, but natural. So too with the Earth. Volcanoes may sleep for tens of thousands of years, their magma chambers quietly shifting, their surfaces blanketed by snow or forest. But deep within, they change. We do not wait in fear. We wait in care. We build communities that can adapt. We support science that listens. We honour old stories that remind us how long the memory of the Earth truly is. To be ready is not to predict the hour. It is to live in relationship with the unknown. Like a sailor watches the sea, not because every wave will rise into storm, but because sometimes one does. And so we keep watch, with seismometers and satellites, with notebooks and knowledge, with empathy and imagination. We teach our children not just where to go in a hazard zone, but how to understand the mountain, how to listen to the signs, how to read the sky, how to feel the rhythm of the earth. This is readiness too, the passing of calm attention from one generation to the next. And you tonight feel that calm attention in your breath, in and out, a quiet preparedness, a stillness that does not deny motion but holds it gently. Because while the supervolcano may not erupt in your lifetime, you carry the story of Yomit, and in that story you carry care. As your thoughts soften now, one last image may float into your mind, a map, not of roads or borders, but of heat. It glows softly like coals under ash. It pulses with ancient energy. Somewhere in the world magma moves, slowly, secretly, and above the world turns, And you may wonder, could watching these deep processes not only prepare us for danger, but also for awe? Could readiness be its own kind of reverence? Next, we'll explore how volcanoes shape not just land or climate, but beauty, the unexpected artistry of eruption, from glass to gem, from mountain to memory. You are quiet again, breathing gently, drifting deeper into the rhythm of the earth. We've lingered at the edge of danger, of readiness. We've stood beside sleeping giants and wondered when they might stir. But now, let's turn towards something softer, something unexpected. Let's turn toward beauty. Tonight, you and I will walk slowly through the places where fire has left not fear, but form. Where volcanoes, long after their smoke has cleared, have left behind art, quiet, lasting and shimmering. Because volcanoes do more than shake the ground. They create. They are sculptors of glass, weavers of minerals, painters of cliffs. And their medium is time. Picture obsidian, deep black, sometimes green or gold in the light. It's not just stone, it's volcanic glass, born in an instant. When lava cools so quickly that crystals cannot form, the result is a surface smooth as still water, sharp as thought. For ancient peoples, obsidian was more than beautiful. It was vital. They chipped it into blades, carved it into mirrors, made tools fine enough to slice a single hair. Its edges can be sharper than surgical steel. From the violence of the eruption comes this, a glass so pure it reflects the world. Or consider pumice, a stone so light it floats. It forms as when lava froths with gas, then cools into a henge of frozen bubbles. Dry, weightless, used for everything from polishing to skincare, pumice reminds us that even fire can be airy, gentle, filled with breath. And then there are the crystals. In the cooling heart of a volcano, minerals begin to arrange themselves, quietly, precisely, into geometric forms. Quartz, feldspar, olivine. Sometimes the chemistry is just right. Time slows, space opens, and something rare forms. Gems. Peridot, a vibrant green stone, is often born in basaltic magma, deep in the mantle, carried upward by volcanic eruptions. Its colour, like the first new leaf in spring, speaks of renewal. Diamonds, too, can rise from deep volcanic roots. Though not made by volcanoes directly, they are carried upward by rare eruptions in a rock called kimberlite, blasted from the mantle in ancient vertical plumes. From unimaginable pressure to the surface of the world, they ride a frozen explosion. We often think of eruptions as endings, but every eruption is also a beginning. The ash that falls from the sky settles onto land and sea. Over time, it breaks down into minerals, it feeds the soil, and where the ash falls thickest, the plants return strongest. Some of the most fertile soils on Earth are volcanic, black, rich and humming with life. In Indonesia, in Central America, in parts of Africa, farmers know this well. Their fields bloom in the wake of fire. It's not immediate. Sometimes it takes years, but the transformation comes from grey to green, from stillness to growth. And it's not just in the soil. The land itself becomes art. In Iceland, you'll find cooled lava fields draped in moss, soft, pale green, undisturbed for centuries. In Ethiopia, volcanoes have created salt plains that shine under the sun like snow. In New Zealand, steaming terraces once formed from volcanic springs, coloured with minerals into hues of pink, white and gold. Even the cliffs tell stories. Layered bands of basalt stack like pages, cooled in hexagonal columns that look as if they were carved by design. You may have seen them in the Giant's Causeway of Northern Ireland, or the Devil's Postpile in California. These shapes are not human-made, but they feel intentional. Order born from molten flow. And what of the skies? After an eruption, light changes. Ash and aerosols scatter sunlight, bending it into colours more vivid than normal. Deep crimson sunsets, violet horizons, golden dawns that linger longer than usual. Painters noticed this. After Krakatoa's eruption in 1883, the skies in Europe became surreal. Some say that's why Munch painted the Scream the way he did. The sky truly did burn red. So here, from the most powerful forces of destruction, comes a strange and lasting grace. Glass, stone, colour, life. And you, now lying in the stillness of this moment, are part of that transformation. The minerals in your body, calcium, iron, magnesium, were once born in fire. The same processes that shaped obsidian shaped you. The same chemistry that cooled in crystals flows in your blood. Your bones are of Earth's breath. And within your mind there is pattern. There is beauty, not unlike the slow formation of a gem. So as you sleep, your body healing in tiny, quiet ways, remember, even eruptions lead to creation. Even collapse can lead to art. There is no need to rush beauty. Like a volcano's cooling heart, it forms over time. It requires darkness, stillness, heat that fades slowly. And when it's ready, it reflects the light. You may picture now a single crystal, angular, resting in cooled rock. It took centuries to grow. It will last for millennia. It carries no memory of eruption, only the shape it chose in its silence. That shape, perfect, quiet, unexpected, is its offering, just as your breath, now soft and slow, is yours. And in this quiet, you may wonder, if volcanoes create beauty, what happens after they're gone? What becomes of the caldera, the emptiness left behind? Next we step into those hushed places, the giant craters once filled with fire, now cradling lakes, forests and echoes. The landscapes reborn from silence. You are resting deeply now, your breath matching the rhythm of the dark earth below. We've wandered through the fire, its glow, its fury, its unexpected beauty. But fire doesn't last forever. Even the greatest eruptions eventually end. And when they do, what's left is not ruin. It's space. Tonight we step into that space, into the caldera. A caldera is not simply a crater. It is not the sharp-edged bowl of a small eruption or a wound left by a falling rock. A caldera is something larger, deeper, quieter. It is what remains when the magma chamber beneath a volcano empties, when the molten heart pours upward in a great eruption, and the surface above can no longer hold its shape. It collapses, not violently, but with a slow and massive settling, a subsiding. The land folds inward, as if exhaling, and what it leaves behind is vast, sometimes many kilometers wide, a place where stone once stood, a place that once rose high, now opens downward. But do not mistake emptiness for absence. Calderas become sanctuaries. In Oregon, Crater Lake lies in the caldera of Mount Mazama. 7,000 years ago, Mazama erupted in a blast so immense it reshaped the region. But now the caldera holds still water, so deep and blue it seems endless. Snow drapes the rim, clouds skim the surface, the old volcano sleeps beneath a mirrored sky. In Indonesia, Lake Toba, one of the largest calderas in the world, stretches out across northern Sumatra. Formed by a super-eruption 74,000 years ago, Toba may have once dimmed the skies across the planet, but today it is a lake ringed by hills, dotted with islands, home to forests and birds. And in New Zealand, Lake Taupo, filling another ancient caldera, hides a powerful volcanic history beneath its peaceful surface. Steam still rises in places, the earth still stirs beneath, but above, the air is soft, the light is calm. These places do not feel like sites of destruction. They feel like places where the earth has paused, where silence gathers, where something immense has made space for stillness. You may picture one now, a great, quiet bowl of land, water resting in its hollow, pines along the rim, mist curling upward like memory, and beneath it all, a deep breath held in stone. It's easy to think of calderas as endings, but they are beginnings too. New ecosystems form within their boundaries. Soil, enriched by volcanic minerals, nurtures strange and vibrant life. Rare plants grow, animals return, birds nest in the crags. Wind curls through the open space. In some calderas, geothermal features remain. Hot springs, geysers, steaming ground. Heat lingers, not enough to erupt, but enough to remind us the earth is still breathing here. And in others, the magma begins to return, slowly, subtly, pushing the land upward again in a gentle inflation. These places may erupt again one day, but for now they hold the balance between what was and what might be. You too carry calderas, not in stone but in experience. Spaces left by loss, by change, by the eruption of something once bright and overwhelming. But in those hollows, something new can begin, not to replace what was lost, but to grow because of it. You are not empty, you are open, and in openness beauty lives. The still water of a caldera reflects the sky more perfectly than any mountain peak. Its surface is not broken by urgency. It waits, it mirrors, it holds. So now, in your own stillness, feel that space within you, that quiet, that release. It is not absence, it is rest. There is more life in a caldera than we first imagine. Artists paint them, scientists study them, hikers walk their rims in silence. Pilgrims visit them, not for the worship, but for wonder, because to stand within a caldera is to be held by the earth, not above it, not against it, but within it. As you breathe now, feel yourself in that space, sheltered by sky, touched by wind, surrounded by near-planned stories. Each caldera tells of fire, each one teaches what happens after, and still the earth remembers. You may notice then that in all our journeys, into magma, ash, myths and readiness, we return again and again to this pattern, rising, breaking, opening, becoming. It is the rhythm of volcanoes, and perhaps it is your rhythm too. So rest now in the hush of this crater. Let your thoughts ripple outward like mist on a quiet lake. And if you listen closely, with your breath held just long enough, you may begin to wonder, if these immense craters can hold water, life, memory, could they also hold time? Could they preserve a record, not just of eruption, but of the Earth's deep past? Next, we sink into layers of ash and sediment, into the caldera's secret archive, where geology becomes history, and sleeping stone holds stories far older than any word. You are safe now, held in the warmth of night, your breath slow and even. The world is hushed, the mind soft. We've walked together into calderas, wide, quiet bowls where fire once bloomed and left behind silence. But beneath that silence, something else remains. Layers. Tonight we sift gently through them, layer by layer, thought by thought, because volcanic ash is not just the end of something. It is a record, a witness, a page in the book the earth writes beneath our feet, and the earth writes slowly. Imagine a handful of ash falling from the sky. It's warm, fine, weightless. It coats leaves, stones, roofs. It mixes with water, clings to skin, settles on the lakes. Then over days or weeks, more dust, more soil, more rain pressed down from above. The ash becomes part of the ground. Years pass, centuries, a forest grows. People walk across it, never knowing what rests beneath. But the ash remains, a soft, pale line in the dark layers of earth. Later someone digs, a geologist or an archaeologist. Their hands move counter through time, and suddenly they find it, the layer, the line of change. It's called a tephra layer, a blanket of ash preserved in sediment. And it holds so much. Each layer can be dated using radiocarbon techniques or measuring how certain elements decay. Its chemistry reveals which volcano it came from, and when. Sometimes layers just a few centimeters thick can cover thousands of square kilometers. Silent footprints of a distant eruption. Some ash layers are known across continents. The Toba supereruption left traces across Asia, Africa, and the Indian Ocean. The Campanian ignimbrite eruption over 39,000 years ago in Italy blanketed parts of Europe in a layer still visible in the ground today. And these layers don't just mark eruptions, they hold climate. They capture what the world was like at that moment. Pollen grains, trapped air bubbles, soot from distant fires. In ice cores from Greenland or Antarctica, thin bands of ash reveal sudden cooling periods, a fingerprint in frozen time. You might think of it like tree rings, each layer of ash a sudden pulse in the Earth's long, slow heartbeat. But more than that, they are connectors. A layer of ash in a cave in Turkey may match one found in a peat bog in Scotland. A layer found in a seafloor core may mirror one beneath a Japanese rice field. The same moment, different places, shared silence. In this way, volcanoes synchronize the Earth's history. They give us fixed points in time, bookmarks in an otherwise drifting narrative. And in between those bookmarks, we begin to read. Archaeologists use ash layers to date human activity. If a village lies above the ash, it came after the eruption. If it lies beneath, it came before. Sometimes entire civilizations are frozen at the moment fire arrived. Like Pompeii. When Mount Vesuvius erupted in 79 CE, the city was smothered in ash and pumice. But that smothering preserved it. Its streets, its homes, even the bread left baking in ovens. A tragedy, yes, but also a time capsule. a snapshot of ancient life frozen in volcanic stillness. Ash is paradoxical. It buries, but it reveals. It destroys, but it preserves. In Japan, layers of volcanic ash help date temples, poems, the movement of people. In South America, ash records ancient farming. In the Pacific, it marks the rise and fall of islands, reefs, and migrations. Everywhere it waits patiently. It is not loud, it is not proud, but it endures. And you, resting now, carry your own layers, memories stacked one atop the other, experiences buried but not forgotten, shaped by heat perhaps, or pressure, but still present. You are an archive too, softly held, quietly recording. And so the Earth and you are not so different. Sometimes we think of the planet as violent, chaotic, eruptions, quakes, storms, but beneath that there is structure, rhythm, a calm logic, a memory that stretches far beyond our own. In Iceland, some homes are built with turf walls, layers of earth insulating against the wind. Within those walls, ash layers remain, visible, delicate, marking times when the skies darkened, when the earth spoke. The houses remember. In New Zealand, tephra layers from Taupo's eruptions appear in lakes, in caves, even in ancient Maori oral traditions. The ground tells the same story as the people, one in chemistry, the other in voice, and in the deep ocean floor researchers core through thousands of meters of sediment to find ashes from eruptions that happened before humans walked upright. Ash is older than memory, but still legible. Volcanoes are not just mountains. They are authors, and ash is their ink. As your breath deepens now, feel yourself drifting into that space, the quiet between layers, the pause before the next page turns. You are safe here among the ancient dust, the old air, the patient silence. And if you could press your ear to the earth, what would you hear? Not shouting, not roaring, but a whisper, a rustle of time, a turning of pages, because under every forest, every plain, every quiet lake, the earth is keeping its own diary, and sometimes it's written in ash. You may begin to wonder, if layers can preserve the past so clearly, might they also predict the future? What might those buried records tell us about what comes next? Next we step not downward, but forward, into models and minds, into the science of forecasting eruptions, into the fine line between watching and warning, and the art of listening for fire before it rises. The night is deep now, your thoughts are slow, like smoke rising from cooled stone. You've rested inside the Earth's archives, traced the quiet history of ash laid down in layers. But now we rise again, not into eruption, but into attention, because volcanoes rarely wake without warning. They stir first, they murmur, and if we listen closely, we might just hear the earliest breath of fire. Tonight, we explore that listening, not the kind we do with ears, but with instruments, patterns, and patience. Because forecasting volcanic eruptions is not fortune-telling. It's not prophecy. It is science shaped by listening. A kind of listening that watches as much as it hears. Imagine a mountain, still, stoic, snow-capped. It hasn't erupted in centuries. But then, quietly, something shifts. Beneath the surface, magma begins to rise. It pushes upward, slow as thought, reshaping rock as it moves. That motion sends out tremors, tiny earthquakes too small to feel. Then more, a cluster, a swarm. Seismographs catch the rhythm. The earth, without warning, begins to speak in pulses. Each earthquake tells a part of the story, where the magma is moving, how fast, how deep. Scientists track these waves, mapping their origin, their shape. A language of stone unfolds. Then come the changes in the ground. As magma rises, it lifts the land above it. Hills swell, valleys tilt. Satellite systems, precise down to the millimetre, measure the expansion. GPS stations surrounding the volcano mark the breath of the mountain. It's as if the earth is slowly inhaling. Next the gases rise. Carbon dioxide, sulfur dioxide, water vapour. They seep through vents, cracks, fumaroles. Instruments sniff the air, measure chemical shifts. If the ratios change suddenly, it may mean magma is close to the surface. Sometimes even the temperature of the ground shifts, and satellites capture it, watching heat bloom like a ghost beneath the soil. All of this forms a web of data, and from this web scientists begin to forecast, not with certainty, but with clues. Forecasting a volcanic eruption is like watching a thunderstorm form far away. You see the clouds gathering, the air thickening. You know something is possible, maybe even likelier, but not exactly when or how strong. And yet this watching matters, because when people know what might come, they can act. In 2010, when Mount Merapi in Indonesia showed signs of rising pressure, thousands were evacuated. The eruption came, powerful and tragic, but the early warning saved countless lives. In 1991, Mount Pinatubo gave off tremors and gas for weeks before its massive eruption. Scientists from around the world collaborated, shared findings, issued alerts. Over 75,000 people evacuated in time. Forecasting is not about panic. It is about partnership between Earth and observer. You may think of scientists as listeners in a long conversation. They study the volcano's history, its behavior, its quirks. They learn its moods. They know when it hums low, when it shifts too quickly, when it changes tone. Just as you, lying here, might notice when your breath changes, when a dream stirs or a thought tightens. It's all listening. And yet, even with the best tools, some eruptions surprise us. Because volcanoes are not machines, they are systems, and every system has complexity, uncertainty, even mystery. Forecasting means holding both knowledge and humility. It means saying, we think something is happening. We don't know exactly when, but we're watching, we're listening, and we'll tell you what we see. In many regions, communities near volcanoes receive alerts, often coded by colour. Green for calm, yellow for unrest, orange for escalating activity, red for eruption. These alerts come not from panic, but from careful study, and they are always evolving. With better instruments, better models, better global networks, our ability to hear the Earth grows finer each year. Scientists now use machine learning, algorithms that process vast amounts of seismic and gas data to detect patterns even humans might miss. They create digital twins of volcanoes, virtual models that respond to simulated eruptions. We are building a vocabulary for fire, and still there is something beautifully human in it. A volcanologist might spend their entire career with one mountain, walking its slopes, watching its vents, listening for the smallest shift. They grow close to it, not with superstition, but with care, like a guardian. They know the smell of new gas, the shape of an old dome, the pattern of birds when the air begins to warm. This is science made of time, of watching and waiting. You resting now are doing the same. Your body listens inward, to pulse, to warmth, to breath. Your thoughts, like sensors, track what stirs beneath. You don't need to control it. You simply notice. You prepare gently for what might come. Forecasting is not just for volcanoes. It is a way of being, to listen closely, to watch the signs, to hold both alertness and calm. And if the fire comes, if the mountain rises, you will not be caught off guard. You will be ready, not because you predicted it, but because you paid attention. So as you soften now, drifting deeper into the folds of night, you might wonder, if we can learn to listen this carefully to mountains, could we also learn to listen this way to each other? Could awareness, attention, and care shape not just how we face eruptions, but how we live between them? Next, we turn from the mountain's breath to the planet's balance, to the question of climate, and how a single eruption might shift seasons, change skies, and ripple through ecosystems far beyond the reach of lava. You are safe here, resting in the hush between thoughts. We've walked close to the mountain's pulse, listened to the subtle signs of rising but now we look upward, past peaks and smoke, past air and weather. Because sometimes volcanoes speak to the sky. Tonight, we explore that rare, powerful connection. When Earth's breath rises so high, it brushes the stars. When ash and gas change the very colour of light. When an eruption, far away, darkens days in places that never saw the flame. This is the story of skyfire. You may imagine it now. A supervolcano stirs. The magma chamber swells. Tremors shake the ground. Then in a sudden release, fire climbs not outward, but upward. In the largest eruptions, gases and particles shoot tens of kilometres into the stratosphere, the layer of the atmosphere above weather, where clouds do not drift and rain does not fall. There, high above Earth's surface, these tiny particles spread into a thin and invisible veil, and they stay. Ash may fall within days, but sulfur dioxide gas transforms into fine aerosols, droplets so small they scatter sunlight. They reflect it. They soften the sun's warmth. And as a result, Earth cools, not dramatically, not immediately, but measurably. After Mount Pinatubo erupted in 1991, global temperatures dipped by nearly 0.5 degrees Celsius over the next year. The skies turned strange, brilliant sunsets, icy dawns. Ice and coral records show the fingerprints of that eruption, far beyond its ashfall. But Pinatubo was not the first. In 1815, Mount Tambora in Indonesia erupted with unimaginable force. Its explosion was heard over 2,000 kilometers away. The ash cloud circled the globe, and the year that followed became known as the year without a summer. In Europe and North America, snow fell in June. Frost touched crops in July. Harvests failed. Hunger slumbered. Paintings from that year, like the haunting landscapes of J.M.W. Turner, show skies tinted with ash-filtered light, strange and beautiful. One eruption, one mountain, and yet the entire planet felt its shadow. Volcanoes remind us the world is connected, not in theory, in air, in breath, in the dust that drifts from one continent to another, in the winds that carry memory from fire to field. But not all volcanic eruptions affect climate. Only those large enough, tall enough, and rich in sulfur make it to the stratosphere. Most stay local. Impressive, but fleeting. It takes a true giant to touch the sky. Supervolcanoes do that. If one were to erupt today, Yellowstone say, or Toba, the sulfur it released could dim global light for years. Crops would struggle, weather would shift, ecosystems might stumble, but we would adapt, we always have. Nature's balance is fragile, yes, but also flexible. Plants evolve, oceans absorb, humans adjust planting, preserve seeds, build resilience. After Tambora, agriculture changed. After Pinatubo, climate science advanced. Today we study past eruptions through ice cores and tree rings. Tiny layers tell us when sunlight dimmed, when growth paused, when skies changed. You might picture it now, a cross-section of an ancient tree. Its rings are wide in warm years, narrow in cold ones. A narrow band, dated to 536 CE, marks a year when something veiled the sun. No records of an eruption survive, but the evidence remains. In trees, in ice, in legends of darkened skies. The Earth remembers in many ways, and so do we. You, lying still now, are made for balance. Your body regulates temperature, filters air, shifts blood to warm or cool, you are sensitive to change, are just like the Earth. And when the sun dims, you notice. When the wind turns, your skin feels it. That connection between inside and outside, between Earth and sky, is what makes you part of this story. Because climate is not abstract, it's breath, it's light. It's the rhythm of seasons, the timing of blossoms, the calm of a spring evening. And when a volcano speaks to the sky, that rhythm shifts. But only for a while. The aerosols settle, the warmth returns, the land breathes again. Volcanoes do not end climate, they only write footnotes, brief chapters, meaningful pauses, and in those pauses, we learn. We learn to build food systems that can flex. We learn to read the signs of weather's memory. We learn to listen, not just to eruptions, but to their echoes. So as you rest now, imagine the air above you. Not empty, but filled with invisible stories. Molecules that once passed through fire, wind that once curled around a crater, light that bent through ash and coloured the sky. Even the most distant mountain may have touched this breath. Even the coldest morning may carry heat from a vanished sun. And in that quiet connection you may wonder, if volcanoes can chill the world, could they also help us cool a warming planet? Could the Earth's own methods hold clues to balancing the future? Next, we consider that possibility, the bold, controversial idea of using volcano-like aerosols not from eruptions, but from human hands. A chapter where science meets ethics and the sky becomes a laboratory of hope and caution. You are quiet now, floating in at a calm space between thought and dream. The world feels balanced. Your breath is steady, your body weightless beneath layers of stillness. We've followed ash into the sky, watched the sun dim under the volcano's breath. And now we ask a bold question. Could we do it on purpose? Tonight, we visit a controversial corner of science, geoengineering. Not science that heals the Earth through trees or soil or oceans, but science that reaches upward, into the air itself, that mimics the mountain, that says, what if we cooled the planet the way a volcano does? The idea is simple to describe but heavy to hold. When a supervolcano erupts, it blasts sulfur dioxide into the stratosphere, high above the weather. Those particles reflect a small portion of the sun's energy back into space, cooling the Earth below. After eruptions like Mount Tambora or Pinatubo, temperatures dropped for a year or more. Some scientists wonder, could we do something similar but safely? Could we, in a time of climate change, mimic the cooling effect of volcanic ash without the eruption? This concept is known as solar radiation management, a form of geoengineering. One proposal: release tiny reflective particles, such as sulfate aerosols, into the stratosphere using high-altitude aircraft or balloons. These particles would scatter sunlight, slightly dimming the Earth's surface and reducing warming. The technique would not remove greenhouse gases, it would not undo emissions, but it could, in theory, buy time, slowing temperature rise while longer-term solutions take hold. Imagine it like pulling a translucent curtain across a bright window. The sun still shines, but more softly. There is logic in it. There is risk, too. Geoengineering stirs both hope and hesitation, because once we reach into the sky, not to study but to change, we must tread carefully. The atmosphere is not a blank canvas. It is alive. It breathes, connects, remembers. Cooling the Earth may change our rainfall patterns. Some regions might benefit, others suffer. Monsoons could weaken, droughts could spread, and once begun, such a project might have to continue for centuries. If stopped suddenly, temperatures could rise sharply, a phenomenon called termination shock. The sky, once altered, cannot easily be unaltered. And yet, the planet is warming. Year after year, glaciers retreat. Seas rise, heat waves intensify, ecosystems strain. For some, geoengineering is a last resort option. A plan B. For others, it's a dangerous distraction. A fix that risks masking symptoms while causes remain. There are no simple answers, only careful questions. Who decides whether to shade the Earth? Who monitors the impact? Can we test the system without triggering unknown changes? Could one nation's solution be another's storm? International conversations have begun. Policies, principles, guidelines. But the sky knows no borders. What floats above one continent may drift quietly into another. Still, experiments are small and cautious. Some involve releasing harmless gases in tiny amounts just to study motion and dispersion. Others use computer models to simulate decades of aerosol injection. Each study adds a pixel to the picture, a thread to the ethical tapestry. And all the while we ask, should we? You, lying here now, know something of balance. Your body keeps it moment by moment, cooling, warming, adjusting. You wouldn't reach for medicine unless the illness was real. And even then you'd ask, what are the side effects? The Earth deserves that same care. We are not separate from it. We are of it. Every breath, every cell born of soil and sun. We must ask not just can we, but how will this change what it means to live under sky? Volcanoes teach us that Earth has always known how to cool itself, but those eruptions came with cost, famine, darkness, loss, geoengineering dreams of keeping the cooling but removing the pain. A careful dream, a heavy one. Maybe we never use it. Maybe the world chooses trees, wind, and carbon drawdown instead. Maybe the mountain's mimic remains a study, never a storm. Or maybe one day it becomes a tool, not a solution, but a pause button. A soft veil across a warming sky, bought with knowledge, caution, and global care. You, in this quiet moment, don't need to decide. Just imagine. Imagine a fleet of high-altitude planes tracing delicate loops across the poles. Their trails almost invisible, their cargo measured by sunlight. Below, cities breathe. Forests wait. The planet holds its breath. Just a little cooler, just a little longer. Not forever, just enough. Enough to buy time, enough to find better ways. And as your breath slows now, you might wonder, if we learn to cool the Earth with particles and plans, could we also warm it again with kindness, with balance, with remembering? Next, in our final chapter, we return to the beginning, to the ancient breathing Earth. We trace the whole arc of fire and silence, risk and renewal, and rest in the truth that even sleeping giants, like us, are always becoming. You are here, at the edge of dreaming. The journey has been long and gentle, through magma chambers and ash clouds, through time-keeping sediments and sky-touching eruptions, through beauty, risk and wonder. This is the final chapter of our slow descent into sleep. A return not to where we started, but to the place where the story always begins, the living earth beneath your feet. You've met the supervolcano not as a monster, but as a memory keeper. A slow builder, a sleeping force, yes, but also a maker of soil, sky and stone. You've seen it shape landscapes, colour sunsets, and cool entire seasons. And now it is quiet again. That quiet is not an ending. It is a breath between chapters. You may imagine the Earth now, not as a spinning rock in space, but as a vast body resting beneath blankets of time. It exhales through hot springs and steam vents. Its thoughts move slowly like tectonic plates. Its memory is deep and layered, stored in obsidian, pumice and fossilized fire. There are no final eruptions, only cycles. You too are made of cycles. Your heart beats in waves. Your breath is tidal. Even sleep comes in rhythms. Slow descents, soft awakenings. Like lava rising and cooling, you reshape yourself in stillness. The earth does not rush, and neither should you. Let go of urgency, of headlines, numbers, and noise. Let yourself sink beneath the surface, where warmth remains, steady and ancient. There is no need to chase rest. It is already here, waiting in the hollow of an old caldera, waiting in the glint of volcanic glass, waiting in the rhythm of your breath. We often look to volcanoes with fear for what they might destroy, but perhaps if we listen differently, they can teach us what it means to begin again, to release pressure, to transform. In every eruption something new is made, and in every sleep something new is restored. You've travelled through molten cores and frozen skies. You've stood at the rim of ancient craters. You've watched light bend through ash, heard the quiet language of seismic hums, and now all of it softens, becomes background, becomes comfort. The earth will continue to turn as deep fires will flicker and fade and flare again, just as they have for billions of years, but for now, in this moment, all is still. You are not separate from the mountain. You are not above it. You are within it, a vessel of warmth and memory, a sleeping volcano dreaming of forests, oceans, stars. So rest now. Let the story settle in you like layers of ash, light, fine, full of memory. Let your breath be slow. Let your thoughts wander like drifting tectonic plates, steady and unseen. And if you're still awake, if your mind is still gently turning, know this: the sleepy physicist is always here, with more science, more stories, more quiet wonder. When the world feels too fast, return here. When your thoughts are loud, return here. When you need a reminder that the earth is older, slower, and wiser than our rush, return here. Thank you for dreaming with me tonight. Until next time, sleep deeply and stay curious.